Someday, whenever you feel like, as we discussed earlier, according to our planned timetable, I think we are like 6 classes ahead. So
Hmm.
I was thinking if someday we could just touch SSAT or SAT.
Okay.
You know what SSAT is?
Yeah, the secondary school admissions test. I had to do it before.
Okay. Okay. So we could touch any of these. You will basically need SAT for your universities. I actually just want you to know that it is exactly what we are doing, but a shorter
Oh,
version and a little trickier version.
SAT?
SAT,
Hmm.
not for those students who are actually doing mathematics constantly. It becomes a problem for those who, in their A levels, they don't pursue mathematics. So that is an obvious case that if you're not studying it since 2 years, you will forget everything.
Mm.
So the difficulty level is, I would say, as of IGCSE or low.
For SAT or for
Yes,
SAT?
for SAT. SSAT is basically in three different difficulty levels for primary, middle, and high school.
I've had to do the middle level before, but now I won't be able to.
You'll be able to do SAT as well. And out of these topics, let's say out of any of the chapter, it would be at least 50% of each of them, the SAT. Because SAT is basically universal for complete entire world. We are doing IGCSE currently. Some students are from GCSE, some are from ICS, FSC, FA, different boards. So they had to get that as universal syllabus.
Okay, so they're both similar.
Yes. Okay, now what are we going to do is sequences and sets. Sequence, as the word states, sequence is a pattern, and set is about something which we will define. For example, if I say set of days, you will know Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. If I say set of months, again, you'll know what we are talking about.
So is
But
it
if
like a
I
number?
say, yeah,
Is it a number or is it like
both.
word? Oh, both.
It is both.
Okay.
For example, if I say a set of months, how many are there? You'll say 12. If I say set of months only, one may start January, February up to December. The difference is in writing. Suppose we say set of days is D. So D is equal to something. Now we'll be doing this. We'll be writing all the days: Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, and Friday. And if I say ND, I'll write 7.
Oh, number
Yeah.
of D.
If we are
Okay.
talking about months, again, we write 12 months. And if we say NM, that means what is inside is 12 elements. Let me
Okay.
close, open this file again. It's getting stuck. Okay. So these will be sets and sequences. Let's get in the detail. Sequence is a pattern. Term. Term is exactly the one which we are talking about. So, for example, we are at a place somewhere and we see some bags, and I can say, look at the fourth one. That would be the term.
Oh, so out of a sequence.
Yeah. Look at the seventh one. That would be the term. For example, if we are talking about something and we are writing even numbers and we write 2, 4, 6, 8, so on. May I say the fourth term is 8,
Mm-hmm.
the second term is 4.
Yes.
And if I question what would be the seventh term,
14.
14. So this is basically term number. And how were you able to answer? Because it is following a set of sequence, a defined sequence. If they were random numbers, we will not be able to answer it. Now, term to term rule. What is term to term rule? Basically,
It's
if we talk, sure, sure, ask your question.
No, no. I know what term to term rule is. It's basically like
Very good.
what the pattern is, like what it's increasing by, what it's decreasing by, what is being
Very good.
multiplied by.
Very good. In this case, we will say add to.
Mm-hmm.
Nth term. So may I say for the same case, nth term is 2n.
Two times the number, yes.
Then uh, rational number is the one which we can write as fraction or as whole number. Terminating decimal is the one that ends. For example, we are talking about 5 by 8. Actually, you don't want to go through the complete division. I'm using calculator right now. So if I do 5 by 8, I'm getting 0.625. So
And
this
that
is
end.
terminating decimal. And if we write like 1 by 9, 1 by 9, and I'm getting 0.1 all the way repeating. So 0.1, and we write a dot here. That is a reoccurring decimal. Set, we just talked about it. Element. Elements are the members inside the set. For example, set of days,
Mm-hmm.
set
So
of
there'd be,
months. Elements are the numbers which are inside that defined set.
so we just write like, so if it asks us for like the element, would that
Yeah.
mean it's asking for the number? And then the set is like
Yes.
the words, basically?
For example, if I say set of days, I will be writing Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. Now, basically, what is D? D is set of days.
Mhm.
And what are the elements? Elements is anything which is written inside that set. And if someone says ND, we count the elements inside the set. Whatever is inside, we call that element.
Oh, okay. Okay. Anything inside the set.
Empty set. For example,
No.
if I say write down the days which start with the letter Q,
Oh, then it would be an empty set
that
because
will
it
be
doesn't.
empty set. Write down the names of days which start with letter T,
Uh, Tuesday, Thursday,
Tuesday and Thursday. How many elements are there which start with letter S?
2.
2. So this is element and empty set and set. Now we were talking about before I close the file that set of days, set of months. What if I say set of even numbers? Now one may get confused. We may think 2, 4, 6, 8 to 10, 12, so on. But we may have a question, how long? Till where? So the limit should be defined. If we are not defining the limit, we will write the even numbers like this 2, 4, 6, 8, and then dot dot, which represents continuity. Or we can define set of even numbers less than 20. And this is the way how sets are written, curly brackets, and elements are separated with commas.
So it always has to have like a end, basically. It always has to tell you the end, or else you just have to put
It
dot, dot, dot.
it should have an end. If
Mm.
no, then we put a dot.
Okay.
Now, what is the universal set? Universal is the complete set. For example, I said number of days starting with S. So we said
Mm.
Saturday and Sunday. with T. So we may have different questions for set of days and we may have different answers. But when we talk about the universal set is the one whole complete. That is 7 days from Sunday to Friday.
So there's nothing else you can add to it.
Yes, exactly. The complete set.
Okay.
Let me do an example with you. For example, we talk about set of numbers less than and equal to 20.
So it's from 1, 2, 3, 4, 5 up to 20.
Yes. Oh, let me draw this. Okay, so if we say set of numbers, let me say I denote it with letter M, is such that it is 1, 2, 3, 4 up to 20. Okay, now
Mhm.
I say that to write down even numbers. E defines even numbers. So we'll write 2, 4, 6, 8. Still, I can use dots because I've already explained the sequence, but they are very less. So I'm choosing to write 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. If we say write down multiples of 3, let's say S is multiples of 3. So
Up
set
to?
from
Isn't
this universal set.
okay.
We're not going outside it. So multiples of 3 would be 3, 6, 9, 12, 15, 18. So these are multiples of 3.
Mhm.
And in the same question, let us say that F is multiples of 7. So set F would be 7 and 14 only. Now, if I say write down NF, my answer would be 2.
A number of, okay,
So what would be NS?
6.
6. So basically, we know N is number of elements. We count them inside those brackets. Now, what is this? This is the explanation of the set. What is S? S is multiples of 3. How many members are there? There are 6 members. There are 6 elements. F is multiples of 7. How many elements are there? There are 2 elements. Where are we selecting these elements from? Even or multiple of 3 or F, or let's say we write prime numbers. So prime numbers are 2, 3, 5, 7, 11, 13, 17, and 19. So each one of this is coming from universal set.
Complete. Okay. So universal sets and like are basically completed and they have like an end to them.
Yes, it is complete set. They have end to them. The end actually depends on the given scenario. If we are talking about number of months or we are talking about months, so we know they are already finite. There are 12 of them. So if we are talking about even numbers and we don't put an end to it, if we say even numbers less than 100, yes, there is an end. But when we say only even numbers, there's no end. Still, we can define set, universal set. That is understandable. There's no ambiguity. We are talking about even numbers. Yes. Is there an end? No. So we know what we are actually talking about. For example, now I say that write down um, multiples of 3 out of those evens. So I know I cannot write 3. It was never there, but I can write 6. then I cannot write 9. Then I can write 12 because we have only even numbers in our universal set.
And also 18.
Consider universal sets anything which is inside the store. You will go into a grocery store to get something. Now, whatever is present is the universal set. If someone tells you to bring apples and they're not in the store, they are not part of the universal set.
Mm.
So the
Okay.
one main set is the universal set. Now let us define them with diagram that would be very much clear. You see this box,
Yes.
anything inside this box is universal. Now we may have few numbers just like this, that multiple of 7 and prime, they could be same. You see multiples of 3 and prime, they could be same. So they can overlap or they may not touch each other. For example, we write even and odd numbers, they will not intersect with each other. But whatever is inside this rectangle is my universal set. This is set A, this is set B. They may have something in common.
Hmm.
So this is universal and the defined sets. Let's see a few more terms, then we'll go into the exercise. Okay, complement. Complement means not there,
Oh,
or
so
we say minus, or we say subtract, eliminate. If I
so
say, yeah, place your question.
it's like an empty set?
No, I'll explain. Let me quickly write a small set so we can also discuss the answers. This is the symbol for a universal set, looking like
Mhm.
an E. So let's say the universal set is defined 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we have E for even numbers 2, 4, 6, 8, 10. Let's say I have M for multiples of 3, 3, 6, 9. And I have P for prime 2, 3, 5, 7, 2, 3, 5, 7. Now, if I say P symbol is this complement, P
Prob P is
complement. We if
P
it,
is
P is prime, and if I say P complement, this is the symbol. P dash is the symbol
okay.
for P complement. And what is actually P complement? P complement is anything but not P.
Oh, okay.
I can see P is 2357. So I will write anything but not these. So 1, missing 2, missing 3, 4, missing 5, 6, missing 7, 8, 9, 10. So that is P and this is P complement. I can say P plus P complement is actually the universal set.
Okay.
Or we can say P complement is universal minus P. A complement is universal minus A.
Oh, there's also like equations for this one as well.
Yeah, only this one.
Okay.
In the entire chapter, in the entire topic, only this one. Or maybe this is my way of explaining. Avoid that. P complement means just don't write P. For
Hmm.
example, we write M complement. So I'm writing everything but not M. Something just happened with my brackets. They should look neat. So M complement is 1, 2. M was multiples of 3. So we don't write them. We miss 3, 4, 5. We miss 6, 7, 8. We miss 9 and 10.
M complement. And then E complement is just anything but the multiples of 2.
Yeah.
So, okay.
We wrote E as even numbers. So we're not writing them. And we write 1, 3, 5, 7, 9. And that's it.
Odd numbers.
This bracket is supposed to look perfect. Okay. So this was complement. Universal means everything. In this case, universal is from 1 to 10.
Mm-hmm.
Set E, M, and P are defined. E is even number, M is multiple of 3, P is prime numbers. And we talked about complement. Complement is not that. Now I'm introducing two more terms. One is union, the other is intersection. We will talk about intersection first.
They have symbols, right?
Yes,
I remember, yeah.
yes,
Union, it's like a U shape.
very good.
Intersection is like an N, I think.
Good
Yeah.
you. Okay, intersection is the symbol. Intersection means common. So if I write E intersection M, so what do you see common in E and M?
6.
6. So our answer is 6. If I say N E intersection M,
1.
1, and this one is without bracket. This one
Mm-hmm.
is without bracket. Only elements are within the brackets.
Okay, because it's not part of a set.
Yeah. So union is U-shaped, but not the actual U. That is U-shaped, not the actual U. It is combining the sets. So if I say M union P, individually we know M is 369. Individually we know P. So may I write 2, then 3, then 5, then 6, then 7, then 9.
Mhm.
No repetitions. Although 3 comes 2 times in M and N P, but no repetitions. So M union P is this. In union, we combine. In intersection, we only write the common part. So till now, we have discussed 4 terms. One is the universal, that is the complete set. Then the complement, that means without that. Then intersection. I just saw bubbles going.
I think it thought you were like showing the age of a birthday or something.
Yeah, maybe, but why is that? I saw that one.
Maybe
If
it's
you're not doing
automatic.
it, maybe it is this gesture.
Maybe.
Maybe.
Maybe it's automatic.
Yeah, because I saw that one another day, but I never saw that in your background. So I just asked my brother if I've done something, please correct it.
No,
Okay, so universal is the complete set. Then we have complement without that, and then we have intersection, the common part, and then we discuss the union, the combination. Union, intersection. I'm leaving these 3 for now. I'm willing to go on to the exercise because the exercise would definitely start from here and lead its way. During practice, we'll absorb them completely.
okay.
These 3
I
are
already
very,
know what it is. Venn diagrams.
oh, very good. I never mentioned that name, but this was Venn diagram. So set builder notation is the when we say this set is defined, basically
Mhm.
that definition is set builder notation, and we'll study how to write that. So Venn diagram and subset is the smaller set out of the given set. I can say E, M, and P are actually the subsets of universal set.
Is every other set a subset of the universal set?
Yes.
Okay.
Now there will be 2 more terms that will be proper subset and only subset. So we'll
Mm-hmm.
discuss them in detail. That is again very easy task. Okay. Starting with the sequences. Sequence can be thought of a set. I'm just skipping this exercise. I know we both understand what we are studying. Like
Oh,
I'm skipping the reading
in
part.
in school we were learning about like basically algebra and like finding like terms and combining like terms basically in school. And we're already ahead of that.
Very good. Very good. The term to term rule, as we can clearly see, we are discussing the sequence 2, 8, 14, 20, 26, 32. When we just look at it and we think a little, we see that every term is actually increasing by a difference of 6. So term to term rule for this given sequence is add 6. So we just have to explain it in words. And then again, you see 1 and then 1 by 2 and then 1 by 4, then 1 by 8. So what do we observe? Every preceding term is actually the half of the previous term.
So would the one like the 2, 8, 14, 20, that one, would it be like what would you times the n by? Would you times the n by
You're talking about this first sequence and you are talking about the nth term.
Mhm.
Okay. There will be a formula, an
Oh,
easy
okay.
one.
Okay.
Currently, I am telling you without formula just to make sense of it for the understanding sake. Can we say we are increasing it by 6 anytime?
Yes.
May I say 6 and
I
whatever
don't
it is or whatever it is? Look at this first 6. I'm adding this 6. What happens when we talk about two terms? We add two 6. What happened when we talk about the third term? We add three sixes and so on. So we are adding these sixes. I'm saying 6n
Mhm.
because 6 is being added. Now, when I consider that I am writing 1 in place of 6, what do I get? When I try this, I get 6. I should get 2.
So you
So how will I
subtract
get 2?
by
Go on, go on, go on.
subtracted by 4.
Subtracted by 4. Now give it a try. What happens when you plug in 1?
It'll equal to 6.
That equals to 2.
It equals to 2, sorry.
So what happens when you plug in 2?
It'll equal to 8,
8. What happens when you plug in 3?
14.
14. So we did a hit and trial and we got our nth term formula and that is correct. How is that correct? We just checked it. We substituted the values and yes, we are getting the correct sequence now through the formula. Formula
So this
for n. Sure, sure. Throw your question. Throw your question.
the formula when it doesn't actually start with what you're adding it by. Like for example, it's not starting by 6, so
Yes, it is
how
not
does your
starting by 6 because 6 is being added in every term. So that's 6n straight away. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. So we multiply it. And then we adjust with this -4 or +4, whatever we have to do. Now, the term formula would be a plus n minus 1 into d. Now, a is the first term, n is the term number, d is the common difference.
so it'd be 2 plus let's say the number is 2 minus 1. So 2 plus 1, 3.
A plus n minus 1 into d.
Uh,
First term is 2. We
mhm.
keep n as it is, and the difference is 6. So when we simplify 2 plus 6n minus 6, 6n is already there. 2 minus 6 is -4. So we get the same formula. When do we use this? Only when we have the common difference.
Okay, wait.
Like constant number is being added.
How did you get 6n?
How did we get 6 and in this red or blue?
Oh, in the red.
In the red. You see that D common difference. That is outside the bracket. So 6 is being multiplied with both the numbers inside the bracket.
Oh, okay. So it's like expanding it.
Yes. Let's
Okay.
quickly do it for two sequences and try to absorb it. So let's say the sequence is 3. This is the sequence. So term number is equals to a plus n minus 1 into d. What is the first term
3
and the common difference?
plus 3. No.
Sorry, I missed one.
Oh. Uh, plus 2.
Plus 2.
So 2.
So now we are simplifying 3 plus 2n minus 2. Simplifying it further gives me 2n plus 1.
2
And
n
we
plus.
always check it. When we put 1, we are getting 3. When we substitute 2, we are getting 5. So this is correct. Another sequence. Term number is a plus n minus 1 into d. First term is 10 and stays there. What is d?
Negative 2.
Negative 2. So 10 negative 2 plus 2 is 12 minus 12. Now this formula actually Tn is equal to a plus n minus 1 into d. This works only for the terms which have common difference. That could be constant increasing or constant decreasing. We may have different sequences. For example,
I think those ones were called, it starts with geo or something.
geometric
Geo,
sequence.
yeah, geometric, right?
Yeah, we'll come to that eventually. Apart from arithmetic sequence and geometric sequence, we do have sequences which are very much part of syllabus and we solve them by hit and trial.
Mhm.
They're not very hard. Can you see what is happening in this sequence?
Yes, these are the square numbers.
Very good. So if someone, you're on the right track. If someone just say the difference is 3, then it is 5, then it is 7, then it is 9, is he or she wrong? That is just the
Mm,
perception.
No, it's
Then
not wrong.
one would obviously know, I'm looking at this, this is 2. So it is yes, following a defined sequence. If I make this difference 2, this would be 13. And when we add 13, this would be 49. But you're right, that was your way of thinking. So that is squared and Tn would be n square right away. Now what happens to the exact same sequence? Not exact same, the new sequence, if I write 4, 9, 16, 25, 36. Now the first term is 4, not 1.
So it'd be still n squared minus, I mean plus, yeah, plus n squared plus,
So you see what we are doing?
mhm.
And trial.
So n squared plus 3?
N square plus 3. Now check when we put 1, do we get 4?
Yes.
And when we substitute 2,
No.
no. So that's a no. Okay.
Mhm.
Another attempt. That was a hit. Another attempt.
Can you like
We'll discuss it. That was actually a jump when we
uh,
started the exercise because you knew something, and yes, you are right. AP, GP, and sequences. So we just made a jump. We just need a quick revision, and you'll be back on track. Just see, I wish to get 4 when I substitute 1. And that
mhm.
is only possible when I do 2 square, that is 1 plus 1 whole square. So I'm thinking about n plus 1 and trying with 1, it gives me 2 square, that is 4. When I substitute 3, that gives me 4 square, that is 16. The third term is 16. So basically my formula is n plus 1 whole square for the term number.
Oh, okay.
So that was hit and trial. And we do have formula as well for this case.
So we're basically thinking of it first like as 1 plus 1, trying to get the first number, but then we do it like the formula with the n+1
Yes.
squared. Okay.
This is entirely hit and trial. This is entirely what we are thinking. And this one was the formula a plus n minus 1 into d. We do
Mm.
have formulas for this, but in most of the cases, teacher will ensure that you should get it without formula. We will study, will definitely study. So in exam, we'll be able to do it without formula because we'll be going through multiple examples. So we will
So it's
actually know which case this is.
so it's kind of like a logics question as well.
Yes, this is a logic question. Basically, it would be for 1 mark or maximum 2 mark. And when we follow the formula, that takes up like around 4 to 6 minutes. But hit and trial would do it in few seconds. Let's see what we have. So one of the sequence was adding 6 to every number. The other sequence is pretty much clear that it is getting half of every number. Half of 1 is 1 by 2, half again is 1 by 4. So we are divide each term by 2 to get the next term. And then we look at 1, 2, 4, 8, 16, 32. Double of 1 is 2. Double of
Mhm.
2 is 4. Double of 4 is 8. So we multiply the previous term by 2. So we're discussing what is actually happening in this to get the next term. So the first one, I can see we are adding 2. So this is my term to term rule. Add 2. Look at this B part. What do you think?
Add 5,
Add 5. C part.
multiply by 3.
Multiply by 3. I was thinking about 3 raised to power n something, but that formula got off track. The question says just to explain. So we multiply it with 3. And D part. Got it.
Oh, plus 1.5.
That's 1.5. E
Mhm.
part.
Subtract by 3.
Very good. F part.
Subtract by 2.
Subtract by 2. G part.
Subtract by 1.2.
Very nice. So that is subtracting 1.2. Last part.
Subtracting.
You're doing it manually?
Subtract by 1.2.
Correct.
Oh yeah, I'm writing it down.
So what we are doing now actually is improving our thinking skill. So we'll be able to do hit and trial very quickly. Find the next three terms in the case. Now he's not asking about the rule and explain the rule. Yes, you have used in each case. You may use your calculator. In fact, in the next class, we
Oh,
do sequences, questions of sequences from a city,
from a city?
from a cities. I just want you to show that it is not difficult. You will find those questions easier than this one.
Mm-hmm. For A, it's timesing it by -3.
Very good. Times -3. So when we actually write the correct answers, it is pretty much the explanation that we got the correct term to term answer. -243 and 729. B part.
Is there like a rule for this one?
Yeah. Monday, Tuesday, Wednesday, Thursday.
So Friday, Saturday, Sunday. But the rule,
Nothing. We just understood the sequence.
oh, so there's no rule
We,
for this one.
so okay, okay. You're talking about this rule. So we'll
Yeah.
rewrite the next day or the consecutive day.
Oh, okay. And then that one's the same, like the next number.
Which one are you talking about?
I'm talking about C.
See, yeah, that's interesting one.
I know it's skipping like one after it and then like getting the next one. No, it's like increasing by the number that it's skipping by.
Yes.
Each one like by one increasing.
So it would be easy if I write he skipped one, then two, then three, then four. Now we have to skip five, then six, and seven. So A B C D E F G H I J K L M N O P Q R S T. So that's U. V W X Y Z. What do I do?
Go back to A.
Go back to A, right? So we have to skip six. V W X Y Z. We skip A and we write B. When we skip seven. C D E F G H I and we write J.
So what would the rule be?
Now this is the interesting part. The rule is never asked in exam. Rule is for us to discuss when we are actually learning this. In class test, we may face the exercise which is asking about the rule. So now the rule, we can explain it, but it would be more words as we answered in 2A or 2B. So we say after the first term, skip one letter. After the second term, skip two letters. So the rule is basically the number of term, skip the same number of letters after that. How am I able to answer it? By after writing this 1, 2, 3, 4, 5, 6, 7. After writing this, I'm able to comprehend that first term we left one, second term we left two, third term we left three, fourth term we left four. So we can say skip the number of letters equal to the number of term.
Oh, yes. So the number of which one it is, then it's the number we skip it by for
Yes.
the next term.
Yes.
Okay. And then
Now this
for
D is a little disturbing one.
there's a repeating. So,
It is increasing, then decreasing, then increasing. So something about that. Let's focus.
and there's no like specific order in which they like
Mm-hmm.
increase or decrease by either.
Quickly, let's go to that writing space and give our hit and trial. So this is 1, 2, 2, 4, 3, 6, 4, 8. Hmm.
Oh, I think I see kind of a pattern with it. So like in it, it's like you add one and then you add zero and then you add two and then you subtract by one. So and then you add by three. So you can see like in the first one it was adding by one, and then the next like the third term you added by two, but the first term's like adding by one, you subtract that by one. So it's like the same for all of them basically.
You're seeing this?
Yeah, but like you can see that like when you add one to it, then afterwards you subtract that number, like the one, or any line, like for the next one it would be um two for afterwards, two, and then you minus that by one, like what is like one less than it. Like and then three would be one less than the three.
If I just write those numbers, I see +1, then I see +0, then I see +2, then I see -1, then I see +3, then I see -2, then we see +4. So we're not actually getting any sequence.
Hmm. But I can like kind of see something. Like
Definitely there is something because this is a certain sequence. Just have a look at the something on right. I just noticed that I'm still processing which words to use. Can you see that jumps in blue?
mm, 2, 4, 6, and
One,
2.
2, 3, 4. Constant increase. 1, 2, 3, 4. Next would obviously be 5 here, then we 6 here, and then 7 in this place. And when I look at the green ones, that is plus 2, plus 2, plus 2, plus 2, plus 2. Just notice the green ones. You see this 0? Then we have, we start with this 2, and through this 4 is 2, then 6, then 8. So 2, 3, 4. It is constantly increasing. If I just look at the sequence, may I say that the odd terms are increasing in sequence, and even terms are addition of 2 in the previous even term,
So the odd terms are increasing
all increasing by 1,
by one, and the even terms are
adding
the
the previous even term.
adding to the previous even term.
This is first, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12, 13 terms in front of you.
Which one are the odd terms?
I'm just highlighting the odd terms. 1, 3, 5, 7, 9, 11, and 13. You see the odd terms, they're actually in constant, they're increasing by 1. All the highlighted 1, 2, 3, 4, 5, 6, 7.
Do you mean odd as in the sequence, like odd, like
In the
different from the
sequence.
others? Okay.
Not actually the answer, the
Yeah,
term number.
not, yeah.
The term number.
And
So
then the
we look at the even terms. These are the even terms. So what's happening to even term 2, 4, 6, 8, 10, 12? They're increasing by 2. And one more thing, if you notice, that is actually equal to the number of term. See, second
2,
term is 2, fourth term
4.
is 4, sixth term is 6, eighth term is 8. So this is an easier explanation. We can say the even terms are equal to the number of term, and the odd terms are increasing by 1.
Okay. So that'd basically be like the rule for it.
Yes.
Okay.
I would say 2 sequences are merged in these.
So combined, like union.
Combined explanation.
Okay.
Relating a term to its position in the sequence. We are already talking about that. First term, second term, third term, fourth term. And think about the following sequence. 1, 4, 9, 16, 25. We already jumped to it. So we knew that first is 1 square, 4 is 2 square, then 9 is 3 square, and so on. So these were squares from 1 to 9. Then we tried from 4, 9, 16, and we got the answer n plus 1 whole square. So notice that the term number has been given the name n. This means, for example, that n is equals to 3 for the third term and n is equals to 100 for the 100th term. The rule that gives each term from its position is term in position n is equals to n square. So term number are these the actual position. Term number is position and the term is the actual answer. Term number is the position and term
Mm,
is the answer. For example, if I write 7, 10, 13, 14, what is the third term?
13.
13. So 13 is the actual answer and term number is the position. Now think about the sequence. Formula is given, obviously. When we are given with the sequence, they'll ask us the formula. Formula is given, they'll ask us the sequence. So when I plug in 1, I get 5, plug in 2, we get 8, plug in 3, we get 11. So given the formula, we can give the individual terms. Continuing this sequence of the table will get this formula is already given. We just plug in 1, 2, 3, 4, 5, 6, and so on. We get all these terms. And we can see here the formula was 3n plus 2. So whatever was the first number, we are adding 3 to every next term.
Mm-hmm.
You see, 3 into 1 means 3 plus 2. 3 into 2 would mean 3 plus 3 plus 2. 3 into 3 would mean 3 plus 3 plus 3 plus 2. So we are adding 3 to the every successive term. So in actual exam, when we are doing this, once we write these two, we just keep on adding 3 in our mind and keep writing it. We don't always use the formula.
But because it's not starting with 3, we have to
Yeah.
get the.
He's concerned with the answer. He's concerned with filling up this table. And we understood the sequence. So yes, we can skip the part and keep adding it. Now see, directly, may I say we are adding 4 to every term.
Mm-hmm.
So 3 plus 4 is 7, plus 4 is 11, plus 4 is 15, and so on. So
So
while,
like the number, for example, 4n just means we're adding by 4 and 3n just adding by 3.
yes,
Okay.
if there wouldn't have been this plus 1, plus 2, or minus 1, anything, that would be the exact same table of the number. 4n would mean table of 4. 4, 8,
Mm.
12, 16, so on. Okay, this is the worked example. Let's just solve this.
For like the sequences that are like continually increasing, like it's not like one specific, but it is increasing by like a specific amount.
Fixed.
Like for example, it's increasing by 1, and then it's increasing by 2, and then it's increasing by 3. Sorry, can I just close that phone for a second?
Sure, sure, sure.
Okay, I'm sorry.
No issue.
I was just saying that like for example, it's increasing by 1, and then it's increasing by 2, like so on, and increasing by 3. So number it's increasing by, it's like not the same for each term, but it's has like a sequence on how it's increasing. So
Yes,
for
yes,
those ones, it would not really be like an equation type rule, but more like a sentence type, if you understand,
yes,
like for the ones that we did before.
yes. Okay. And now let me tell this sentence to you because you're a thinker. One thing, you are thinking about a sequence that is possible in the real world. Yes. Do we have a formula for that? Yes. Two things. You just placed a sequence right there. That is correct. And you tried to explain how we're getting the next term. So those words you use is actually the rule. So we can write
Mm-hmm.
the sequence. Yes. We can write the rule. Yes. Do we have a formula for that? Yes. Now a clear boundary. Now a clear boundary after these three yes. Boundary, syllabus. Is it in our syllabus? Few of the examples, yes. Few, no. We can do all of them, but we'll clearly tell each other. You'll tell me the question and I'll let you know if it is in your syllabus or not. But we can always solve it. For mental peace, for sake of discussion, for sake of knowledge, we will always solve it and we'll put a clear boundary. Just like the one I said that we will be going for hit and trial. We do have a formula and that is exactly the same which you discussed. Now let me show you. This becomes very easy when we write it down. I will come back to this after we discuss what you said, this highlighted. Okay. Now name any number.
3.
Let- Okay, 3. I was trying to make it easy for me. 3. So we add 1 and this is 4. Then we add 2. Then we add 3. Then we add 4. Then we add 5. You were talking about this, right?
Mhm.
May I say the difference is 1, then the difference is 2, then it is 3, then it is 4, then it is 5. May I say this is 1, 1, 1, 1. Now I'm going back to the one I highlighted.
I think you made a mistake with the 9 and the 10.
Okay, let me do it. 1, 2, 3, 4. That should not be 10. This is
13.
1, then 2, then 3, then 4, and then 5 is 18. 1, 2, 3, 4. All other is correct. Done? Now just remember this one in green. All these one are same. I'm going back to that example. You see, all these twos are same.
All increasing by
So
2 like that.
what we did, this formula, a plus n minus 1 into d, we are having the common difference in exactly the first time we subtract them. Just
Mhm.
like this one. Minus 2, minus 2, minus 2, minus 2. We call this first difference. Now coming to this one. This 3, 5, 7, 9, 13 is called as first difference, and this 2 is known as second difference. When we have first difference constant, we use a plus n minus 1 into d. When we have
Mhm.
the second difference constant, we do have a formula, yes. We'll ultimately do it. I'll let you know, we'll discuss it. But we have to train ourselves to do it without formula. That is quick, that is fast. And in many questions, you'll have part A, part B, part C, which will actually lead you through that thinking process and you'll be able to do it without formula. For our class, we are not sitting in exam. I'll do it quickly with the formula. Now, one is an square plus bn plus c. Before we proceed, we should know a is equals to first term. N is equal to term number. B is equal to, I'm writing by solving. And C is equal to zeroth, zeroth term.
What does a 0th term mean?
Here we go. Now, if I write an square plus bn plus c, we know this is the general formula. By the time I fill it up, a is the first term. Sorry, a is the half of second difference. Let me correct that. Half of second difference. Now we see second difference is 1.
Yes, yes,
This
yes.
complete is the first difference, not the
And
1, not the 2, not the 3. This complete is first difference. So second
yeah.
difference is 1 half of second difference. We done with A. C is the zeroth term. We already knew this is the first term, this is the second term, this is the third term. So zeroth term will lie before that. May I
Mm-hmm.
say I need to know this term? So I'm following my sequence and coming back by 1. So when I come back by 1, this is 0. When I come back again, this is 3. Do we agree that zeroth term is 3?
If we're Yes, because we're coming back by 0. There's
Yes.
nothing we're coming back by. Yeah, okay.
Just to discuss and understand, we do one more. We're coming back by 2. So 3 minus 2 is 1. When we come back by 1, we get 0. So zeroth term in this case is 0. And zeroth term in this case is 3. So I
Mm-hmm.
got C. 1 by 2, this is Tn. 1 by 2 n square plus bn plus 3. Now B is by solving. So select any of the term, 3 to 18, any term.
9.
9. We chose 9. We know this is the fourth term. So n is 4 and term is 9. May I write 9 when n is 4? The only unknown were Tn, B, and N. So we knew N and Tn. So term was 9 and term number was 4. Solving. 9 is equals to 4 square is 16 by 2 is 8 plus 4b plus 3, 8, 9, 10, 11. And we get minus 2. Minus 2 is equal to 4b and b is equal to negative 1 by 2. So an square plus bn plus c. A is 1 by 2n square. This is negative 1 by 2n plus 3. Now we're checking if we got the correct answer. I know when we will put 3, I should get 6.
Mm-hmm.
So we can check it with any random number. So 1 by 2, 3 square minus 1 by 2, 3 plus 3. So c square is 9 by 2, 4.2. 3 by 2 is 1.5 plus 3. So 4.5 minus 1.5 is 3 plus 3, we're getting 6. So this is the formula.
So for it's basically we use the original formula, but for different sequences, it might like change how we do like the formula basically.
Yes. Now
Okay.
this is one method. There's one more. A plus n minus 1 into d plus d by, this is d1, d2 by 2 into n minus 1 into n minus 2. Now this a is literally the first term, which was 3. 3 plus n minus 1, and the first difference was this one, plus second difference by 2 is 1 by 2 into n minus 1 into n minus 2. I'm simplifying this. So 3 plus n minus 1, 1 by 2. So n into n is n square minus 2n minus n plus 2. And 3 plus n minus 1, n square by 2. This is actually 3. So minus 3 by 2 n plus 1. Now we join the like terms. This is 1 by 2 n square. Now these two is giving me 1 minus 3 by 2 is giving me negative 1 by 2 n. This positive 1 and negative 1 cancels out and I'm left with 3. So you see this and this right there. If I can zoom out, you
Is
see
the
these
exact.
two are
Mhm.
exact same.
One.
So I know 1% of my student. So I didn't deliberately tell you the formulas first.
What like
And
the
we'll do it without formulas in exam, inshallah.
okay.
Your question?
No, the green one is like longer to memorize, but
Yes,
it's like
but easier to solve.
yeah.
That because all of the values are just plug in.
Yeah.
A
It's
is
like
the first term, the first difference, second difference, nothing else.
mhm, basically.
And if I say we will go for hit and trial for this sequence, we may fail to write the formula. Whenever the
Mhm.
examiner is going to ask you a question, it will have a specific difficulty level. It should be possible to solve in the given time and according to the given scenarios. We'll discuss questions and you'll understand. We will do an exercise of SAT tomorrow for the same topic.
Mhm.
Okay. Let's do one worked example. Draw a diagram to show the rule that tells you how the following sequence progresses and find nth term. Okay. 2, 6, 10, 14, 18, 22, and 26. Now I'm thinking what is actually happening.
Adding by 4 plus 4.
I wanted to think about it. Okay, plus 4. And I was actually irritated with this blue color and I planned to write it here. And also, this happens with me personally. When I rewrite it, my mind actually works a little better. Maybe when I'm writing, I'm also thinking, very good,
Mm-hmm.
plus 4. So find the 40th term of the sequence. Find the nth term. So first we write the nth term, sorry. So a plus n minus 1 into d. We know a is 2 and d is 4.
4n minus 2. So we just have to do 40 times 4
Very nice.
minus 2. So 158.
158. C part says explain how you know that the number 50 is in sequence and work out which position it is.
Then we can just do 4n minus 2 equals to 50.
Very good.
13?
2, yes, 13. I subtracted 2. So how
So
do we actually explain it? We know 4n, so multiples of 4. 50 is actually 2 less
2
than the
less.
multiple of 4. That is 4 13 times is 52. Explain how you know that the number 125 is not in the sequence.
Because it doesn't fit with the equation.
That is right. And if I just write it, 125 is equal to 4 and minus 2. And when
Mm-hmm.
we bring this 2 here, this becomes 127 is equal to 4 and we can say 127 is not a multiple of 4.
Oh, that was what I was trying to say. Like, it doesn't fit in with the equation,
Very
but I
nice.
think I said it wrong. Okay.
Let's see.
127, not a multiple of 4.
What I perceived from your wording was that we are not getting the exact value of n, maybe in decimals. I just perceived that.
Mhm.
So, yes, we will also work on this. My teacher used to say, choose good words. 3 different sentences may be correct. And how will we know what are the good words? We will study the marking scheme.
Yes, Cambridge, especially like the curriculum is very like specific about how words like they want us to use.
Words and terms. And luckily for mathematics, it is very easy. You
Mm-hmm.
have to be careful for chemistry, physics, and other subjects. For mathematics, examiner clearly states that he will check your mathematics, not your English, not your science and mathematics. So we are at a very good standing in this subject. We don't have to worry about it.
Mm-hmm. So we would just write like that, like basically the equation and then show that 127 is not like a multiple
Not
of
a
4.
multiple of 4. Yes.
Okay.
Or in other words, just like we explained for the 50.
So by writing it down, the equation.
Like, yeah, the equation and we'll solve for it and we'll get an, let me quickly do it. This is 127 by 4. And we can say that is not giving us the integer term number.
Mm-hmm.
So that should be an integer number. That should be a concrete term number.
Okay.
And let's see what is he explaining. Since n is the
Yeah.
position, the same, not the whole number. And on the other side, divide by 4 is not a
So,
multiple of 4.
yeah.
And so on.
They're also solving it and then it's not working. Okay.
So tomorrow we'll discuss few questions which will definitely improve our thinking skills regarding sequences and give us a little mental peace that SAT is not what everyone says, that it's too hard. Yes, it is for those who lack practice. So
That's the, that's the same for everything. If you like practice on something. But yeah, okay.
that is same for everything, but sometimes, for example, if you appear for SAT 2, that was compulsory at my time,
Mm.
but it is not right compulsory for now. That is just for the students who would want to make their application stand out. That they've done their O levels, they've done their A levels, they've done this SAT 1, and in addition to that, they've done SAT 2. SAT 2 contains subject test. For example, physics, mathematics, chemistry. We have many subjects. You will choose those subjects only which you wish to appear for. For example,
Mm.
you're going for sciences, you will choose physics, chemistry, math, biology. If you are going for business subjects, you will need only mathematics. If you are going for like foreign affairs or something like that, you may need to or wish to appear for world history. So that is your choice. That is not compulsory. But
From on, like students, because I know the college board and stuff, they like are trying it out for a little bit. They're not making SAT like compulsory for like college applications, but I know that some students also still do it just to like just normal SAT to make it like also stand out. So now time.
they do that. If we talk about UK, SAT is not compulsory. If we talk about US universities, in many universities they do accept SAT as their entry test.
Mm-hmm.
So just like SSAT, following the sequence.
Yeah,
And
until 26, it said, I think. But yeah.
Australian universities, they too give an exemption of this test.
Mm-hmm.
So it is not compulsory at any time if you wish to appear for SAT or ACT. Now, this is something actually the person, the organizer, who is in communication with me and your father. So basically, on day one, he told me that we are planning something, which your father is planning for you, that you should be able to do it very smoothly. And I requested them that let me complete sufficient topics so I can relate.
Mm-hmm.
Not every topic is in SAT. And
Yeah.
sometimes I was like, that please allow me to make that decision. I don't want this mathematic to become irritating. Definitely 2 plus 2 is 4 in IGCSE, SAT, ACT, SAT 1, SAT 2, Kangaroo, anywhere. Math is not going to change. We just have to define the syllabus boundaries. Nothing else. Inshallah, you will enjoy that exercise. We'll do it tomorrow. And now we are at the stage that we can relate our current topics with those which will appear in exam. And difficulty level for those questions is lesser than this.
Hmm. Okay.
Anything you would like to ask? Anything you want to ask from this exercise 9.2, 8.2, 9.2, this one?
Mm. No, I was able to answer all of that.
Very good. Okay. Now the question is increasing the difficulty level a bit. Square numbers such as n square,
Mm-hmm.
when number is 1, 1 square is 1, 2 is 4. This is the first, this is second, third, fourth, and fifth. So square numbers from an infinite square 1, 4, 9, 16, 25, 36, and so on. Square numbers may also be used in other sequences, as we can observe in the given line. This is 1 by 4, 1 by 9, 1 by 16, 1 by 25, and so on. We can predict it, and I can say this is 1 over n square basically. And if I'm starting with 4, this cannot be 1 over n square because 1 would be 1 by 1. I can do is n plus 1 whole square for this sequence. Now
Which
when we plug for this one,
so it's not n squared.
no, we will plug in 1 and c. Then we plug in 2 and c if we get the right answer. So 1 plus 1 is 2, 2 square is 4. I'm getting the first term.
Oh,
And then
because
1,
I have one, like the other sequence.
yeah, that
Yeah.
would be, this is n square only.
Mhm.
And then the cube number, 1 cube is 1, 2 cube is 8, 3 cube is 27. So when we look at it, we can predict that these are cubes of the given sequence. Triangular numbers. Triangle numbers are made by arranging dots from either equilateral or right angle isosceles triangles. Both arrangements give the same number sequence: 1, 3, 6, 10, 15. So, and another thing which we can notice is when you see the difference, this is 2, difference is 3, difference is 4, difference is 5. And when we recheck the difference in the new numbers, that is same. All of the second difference is 1. First difference is different.
So the
In
ones with
triangle,
the second difference, the formula was um a squared plus b, an squared
an
plus
square
b squared
plus b
plus
plus c
c. Yeah,
is 1. And the second is
the long
a
one.
plus n minus 1 into d1 plus d2 by 2 into n minus 1 into n minus 2. Let me check it quickly. It was by 2. Yeah, n minus 1, n minus 2. That was by 2. So triangular numbers from the infinite sequence, we'll see which one we are comfortable with. And obviously this is a bit quick. So triangular numbers, the example is this: 1, 3, 6, 10, and 15. Fibonacci numbers. Leonardo Fibonacci was an Italian mathematician who noticed that the natural pattern produced the sequence. Now what is he doing? He's adding those two numbers. So first two numbers, 1 plus 1 is 2.
And then one
Now
plus
he's adding these two. 1 and 2 is 3. 2 and 3 is 5. 3, 5 is 8. 5, 8 is 13. 8, 13 is 21. 13, 21, so on. So generating sequence from patterns. The diagram shows a pattern using matchstick, pattern 1, pattern 2, pattern 3, and so on. So when we are looking at it, this is pattern number, and we are writing the number of matchsticks, we are counting it. So first one is 1, 2, 3. And the second it is 1, 2, 3, 4, 5. And the third one, 1, 2, 3, 4, 5, 6, 7, and so on. Now when we notice the difference is 2. So we keep on adding 2 and we get the uh, numbers of matchstick in the pattern. Now because it is having a constant difference,
two.
common difference, we can write a plus n minus 1 into d, where a is the first term, n minus 1, and d is the common difference, which is 2. 3 plus 2n minus 2. 3 minus 2 is 1. 2n plus 1. Worked example. Let's see this question. The diagram shows pattern made with squares. Pattern 1, pattern 2, pattern 3. Construct a sequence table showing the first 6 patterns and the number of squares used. Okay. So if we have to consider the table, this is 1, 2, 3, 4, 5, 6. I'm counting the number of boxes in the first pattern. 1, 2, 3, 4, 5, 6, 7. And the second one is 4, 4, 8, 9, 10, 11. Third one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I see we are adding 4. So when we add 4, this is 19, 23, and 27.
So 4n plus 3.
4n plus 3, yes. Find the formula for the number sequences in terms of pattern. Good.
Pattern 100. So I just have to plug it in.
How many squares will there be in pattern 100? Yeah.
So
So
3.
is 403. Very good. Exercise practice questions. For each of the following shape sequence, draw a sequence table for the first 6 patterns, taking care to use the correct letter for the pattern number and correct letter of the number shapes. Okay. This is A, B, C. For these, draw sequence table for the first 6 patterns, taking care to use the correct letter for the pattern number and correct letter for the number of shapes. So if we just draw this, that n stays as it is, which is 1, 2, 3, 4, 5, 6.
And then
And sorry,
m is like 4, 7, and then 10 up to 3.
yeah, m is 4, 7, 10, 13, 16, 19.
3n plus 1.
And use the formula to find the number of shapes. Find the formula, yes. 3m plus 1. Oh, very nice. Use your formula to find the number of shapes used in 300 pattern.
901.
Is 901. B part. So it goes in the same manner. N stays as n. And I'm using the same table for this. It definitely says this is pattern 1, pattern 2, pattern 3. That was n. So I'm just considering that for now. And it gives me the number of circles. That is 1, 3, 5, 7, 9, 11. They're adding 2, 2.
2
So
and
what would the
4.
formula be?
2n minus 1.
2n minus 1. Very good.
And then it's
And
601. I mean, 599.
599. That's right. Let's try some more questions. Find the first 3 terms and 25th term of each sequence. First 3 terms and 25th. Okay. So we just plug in 1 and we get 4 plus 1 is 5. Then you plug in 2, 8, 1, 9,
13.
13, and the 25th term. 4 into
101.
20, 101. So this is 101. Let's try this B part.
-2,
Yeah,
1, 4,
that's right. And
25,
25th term,
70.
correct. Let's try this H part.
1 is 2, 2 is 4, 3 is 8, and then the 25th. Mhm.
That's a large number.
Yeah.
I'm getting this on calculator.
300. Oh,
Double three, five, double four, three, two.
okay.
Question number 2. The numbers 30 and 110 are found in a sequence. Formula is given. In which position is each number found?
So we just have to do like n minus 1 and outside n equals to, let's say, 30.
Yeah.
Okay, so 2n minus n equals to 30. No, n
N square.
squared. Yeah, n squared minus n equals to 30.
Yeah.
How did you do this one?
Okay. It says when it is 30. So we just substitute 30 equal to this formula. The number of term is unknown. So we got a quadratic form, that is n square minus n is equals to 30. Now I've rearranged it in the second step and go went for midterm breaking. We can also use quadratic formula. I'm getting two answers, -5 and 6. We know number of term cannot be negative. So the answer is n is equals to 6.
So how did you break it?
Multiplying the two numbers, I should get -30.
Mhm.
Adding the two numbers, I should get -1. So I choose -6 into 5. And when I add these two, I get -1. When I multiply these two, I get -30.
Mhm.
Then in the next step, taking out common from first two and last two. Then writing the brackets which are common and ultimately equals to 0. Quadratics, midterm breaking, factorization.
So you take out one of the brackets and we keep the other one?
Well, let me write it here. This is n square minus n is equals to 30. Then we have n square minus n minus 30 is equals to 0. What we do is we always multiply the first one and the last one. So product I'm getting minus 30 n square, and sum I should get minus n. Whatever is in between, that should be the sum. So writing it again. Now I'm thinking of two numbers, and I like 1 into 30 is 30, 2 into 15 is also 30, but when I add these two or subtract these two, I'm not getting 1. 3 into 10 is 30, and so on. So 5 into 6 is 30. Now these would be adjusted. 5 6 times 30 and 5 and 6 subtracted, I can get minus 1. So n square minus 6n plus 5n minus 30 is equals to 0. Now when we multiply these two, I get negative 30n square.
Mhm.
When I add these two, I get this negative n. Now we take out common out of the first two and last two. So n, this is n minus 6. Common from the last two, 5, that is n minus 6 again. Now if you observe, these two brackets are actually same. So we can still take out common. Either we write this first or later, makes no difference. N minus 6 into n plus 5. If you multiply it again, you'll get the previous step. Is equals to 0. Now the first bracket equals to 0. Second bracket equals to 0. So this gives n is equals to minus 5, and that gives n is equals to 6. And we know that number sequence cannot be negative. It is either the first term, second term, third term, and so on. No negative terms. So that is why answer is n is equal to 6.
So when we like multiply the two brackets together, n minus 6 and n plus 5, they equal to the one like
First line,
yeah.
any of the step before that.
Sorry?
It would equal to any of the step before this step.
Hmm. Okay. Eight. So how did we also get n plus 5? I know when you do it, like it still equals to it, like the past steps.
M plus y. These two. Now we write them as multiple of factors.
Mm-hmm.
One is n minus 6, the other is n plus 5. Basically, what I've done is I've took out n minus 6 as common.
Mm-hmm.
If I just take out these two out, n minus 6. Now what am I left with? This first one n, then this plus 5. So what happens if you multiply this complete with n
N squared.
and complete with 5? So you will get n minus 6 into n plus n minus 6 into 5. Reverse of that. This complete into n and then this complete into 5.
I still don't understand how we got one, like n minus 6. I know we took it out, but so we only take one out.
Which one? Like 1n?
No, I know we like for n minus 6 and the other n minus 6, I know we are on like take it out like we take it out, but do we only take one of them out so the other one's left?
We always take out the one which is same. For example, we have x square y cube plus x y square. Now what will we do? We will see what is same in both of these, and x is same. Then we'll see that y square is same. So I took out x and I took out y square, so I'm left with xy. On right hand side, I'm left with nothing, so I write 1. Now writing this again, n into n minus 5, n into n minus 6, n into n minus 6 plus 5 into n minus 6. Now don't consider them as separate numbers. Just see if this is 1. This full is 1. Both of these are same numbers. Let this be the first one, this be the second one. And then this first one, this the second one. So we see these two are same. I'm picking them out, n minus 6. And what am I left with? When I take this n minus 6 out, I'm left with only n. When I take this n minus 6 out, I'm left with only 5. So if we multiply it back again, I'll reach the second last step.
So we take the n minus 6's out because they're the same.
They're the same. For example, we write x plus 2, 3 into
Mhm.
x plus 2 plus x into x minus 4, or let's say x minus x plus 2, sorry. Now we see these two are same. I can take them out as common, x plus 2. And what am I left with within this first one? X plus 2 is already taken out. I'm left with only 3.
6.
Now x plus 2 is already taken out, so I'm left with only x.
Oh, so we're taking it out as a okay.
Common,
Because
yes.
I thought we were like, like taking both of them off, and I was confused why. Okay. Okay. So one of them remains. Okay.
We'll do the b part and it would be more clear. So this was n square minus n, and now in this case it is equal to 110. Let me just show you this question number 2. The
Mhm.
next is 110. So we're going to find the number of term when it is equal to 110. So n square minus n minus 110 is equals to 0. Now we have to think of two numbers which we will multiply and get 110 n square. And when we add them, product should be this and sum should be minus n.
Negative 11 plus 10.
Very good. So this is n square, that is minus 110, and negative 11 plus 10. So when we add these two, we do get negative 1. When we multiply these two, we do get negative 110 n square. Now I'm taking out common out of the first two, which is n and n minus 11. Then common in the second two, n minus 11.
And then one of them remains, so minus 11. And then n plus 10.
Right. And finally, values of n.
And then the one that's not negative. So n equals to 11.
Yes. So this one's rejected, and this is our answer. Question number 3 says which term in the sequence this has a value of 167. Un is equals to 2n square plus 5. So n is unknown and un is given 167.
So 2n squared plus 5 equals to 167.
Yes. So 2n square 167 minus 5.
9?
Yeah.
N equals to 9. N equals to
Yes,
9.
that's right. Okay. Question number 4. For sequence un this, determine the value of the 10th term.
153.
153. Yes. B part. The value of n for which un is 45. Are you doing 4B?
Yes. Is it n equals to 6?
Yes. Okay. Fifth says the term-to-term rule for sequence given as un plus 1 is equals to un plus 2. Un plus 1 equals un plus 2. Do you understand this subscripts?
What does it mean when it's like on the bottom of it?
Yeah, bottom is subscript, at the top is superscript, that is power. But this would mean like if I use n1, that would mean this is the first term, and on the left hand side, this is second term. When I use n2, second term would come here, and this will give me the third term. So basically, may I say whatever the term is, we are just adding 2 to get the new term.
Mm-hmm.
See, when I add 2 to first term, I get second. 2 to second term, I get third. When I add 2 to the third term, I get 4 because that's n. That's one more than that. So basically, un plus 1 is equals to un plus 2, and it says explain in 2 words what this means. Exactly what we discussed. Add 2 to get the next term. Be marked. Given that u3 is equals to minus 4, list the first 5 terms of the sequence. So I already have u3 is equal to minus 4. If we just use the formula, this should be u3 is equal to u2 plus 2. Minus 4 equals u2 plus 2. 2 goes on the other side. Minus 6 equals u2. And we needed the first 5 terms. u1, u2, u3, u4, and u5. So I already had u3, which is minus 4, got u2, which is minus 6, and we knew that we are adding 2 to get the next term. So when we add 2 to minus 4, we get minus 2, another 2 is 0. And if I'm coming back, I'm subtracting that 2. So these are the first 5 terms. Okay, rational and irrational numbers. Rational are those which we can write as whole numbers or as exact numbers or as fractions, whereas irrational numbers are those which cannot be written as exact number or they cannot be written as fractions. For example, irrational numbers are all uh, non-squared square roots. For example, I write square root 7. If I just write square root 16, that would be 4. Square root 25, that would be 5. These are perfect squares.
Pi and
So
irrational.
pi, yes, pi is irrational and all non-perfect squares are irrational. You already know about decimals and how they are used to write down numbers that are not whole numbers. Some of these numbers can be expressed as fractions. For example, 0.5 is 1 by 2, 2.5 is 5 by 2, 0.125 is 1 by 8, and 0.333. This is known as a reoccurring decimal, could be written as 1 by 3, and so on. Any number that can be expressed as a fraction in its lowest term is known as a rational number.
So repeating decimal, I mean like repeating numbers in decimal, recurring ones, they're still rational, but ones
Decimal fraction.
that don't really have like pattern,
Yeah.
then rational. Okay.
That can be expressed as a fraction.
Mm.
So yes, this can be expressed as a fraction. So it is a rational number.
Wasn't there like a fraction for pi as well? It was
Now,
like no.
22 by 7 is not equal to pi.
Okay.
22 by 7 is actually a little more than that.
So people, but still
Or
they, yeah. It's
for,
not.
mensur- for mensuration, we used either value of pi fed in calculator or 22 by 7 or 3.14. All three are slightly different from each other.
To make it simpler.
Yeah,
I'll, okay.
because we never use the exact values. Whatsoever will we get, and when we round it off, we somehow end up in the same answers.
Okay.
Okay. Notice that there are two types of rational numbers: terminating decimal, that is those with the decimal part that doesn't continue forever, and recurring decimal, the decimal part that continues. Continues is 1 by 3, that is 0.33, and so on. Recurring decimals can be expressed by using a dot above the repeating digit. So we have three examples. If zero point 0.3 is repeating infinite, we write 0.3 and dot above that digit 3. Now you see this is 302, 302, 302. So a dot on 3 and 2 that shows that this set is repeating itself.
Can we also put like a line on top of it?
Dot is a standard.
Okay.
For our calculation base, if like we have the question in sequence as we did in the last class, yes, we can do anything. Draw a line or mark it within a square.
Because our teachers used to like draw lines on top of it. But okay.
Sometimes that is for ease of writing.
Mm-hmm.
During class, that is ease of writing. You mean like this 0.45 and dash. Because somehow when we talk about this, when we draw an arrow, that's a vector. And when we mark, this is a line segment basically. And when we do this, A, B, this becomes magnitude. So there are different symbols for different things.
Mm-hmm. That means it's like it's just a line that ends.
So 4545 is repeating itself. Converting recurring decimals to fractions. This is interesting. What can we do with a decimal that continues forever but does repeat? Is this kind of number rational or irrational? As an example, we will look at number zero point 0.4. We can use algebra to find another way of writing this recurring decimal. So this is the first worked example. If x is zero point 0.4 dot, that means it keeps repeating. Then 10x is you just move the decimal one place to right. Now when we subtract these, I'm getting 9x equal to something. So x is equals to 4 by 9. So basically 0 0.4 repeating infinitely is 4 by 9.
Mm-hmm.
Let's try for this number.
And then we times it
Uh,
by, is it always 10? Or
No,
can, for this one is 100.
that would be, yeah, this one would be 100. So x is equals to 0 0.454545 and so on. Now 100x is going to be 45.4545. Whatever is repeating, we use that. For example, in 0.302, we would be using 1000x.
Mm-hmm.
So I'm subtracting these to get 99x is equals to 45. X is equals to 45 by 99. We
Okay.
actually write 10x or 100x first. I did it in the reverse order. So 45, I'm just checking by 99. I get 5 by 11. 9 5 times, 9 11 times. And this is giving me, this 5 by 11 is giving me 0.4545 and so on.
Okay.
Use algebra to write each of the following as fractions. Simplify your fraction as far as possible. Okay. So this is already done in the previous part. Worked examples. Let's see. What do we have in exercise? Hmm. These are good examples. Let's first go through these. Now, point three is actually simple.
Mhm.
We know this is single digit, and with 10, this will suffice our purpose. And point 24 is relatable with 0.45. I'm coming to C, 0.934. The C part is 0.934, and that keeps on repeating 0.934, 0.934, and it keeps on repeating in the third digit. So we using X and 1000X. And
So
when we subtract them, we get 999X equals 934. Your question?
no.
Okay. And then we make X the subject. And what happens in this case? This is 0.52, and then that's a 4 dot. That means 0.52 is not repeating itself. This will be 0.52444 and so on.
Mhm. So for this one, we would still have to do it like with 1,000.
Yeah, where it keeps repeating itself because I need to eliminate all those decimal numbers and
Mm-hmm.
get some complete numbers. So if we just look at this, X is whatever it is, 100X is, it leaves the first two and then so on. And when we subtract these two, what do we get? We actually want to eliminate all the decimal numbers that are after which are reoccurring. In this case, in C part, this is 934, 934, and so on. So after the decimal 934, we would be able to eliminate it. So if I just take 10x, that is one is 0.52, that would be 5.2. But when I subtract these two, I'm not getting rid of the decimals. So that's why we take 100x and 1000x. And when we subtract these two, we get 900x. But on the right hand side, I am getting rid of all the decimals.
So we both do like 1,000 and then 100, and that allows us to take off all the
Yeah.
decimals basically.
Yeah, let me extract this data. For example, we have the same number and x is equals to 0.52, which is the original number.
Mhm.
And let's say I write 10x. That would be 5.24 repeating. If I subtract these two, will I be able to subtract all the remaining repeating number and get a whole number?
No.
So that's not possible. So I'm rejecting it. And now I'm checking for 100x. I'm looking at the first number. That would be 52 now. 52 triple four or tetra 4. Now, if I just look at x and 10x and 100x, we subtract any of the given options. Still, I'm not getting rid of the decimals. So there should be something that whenever we subtract them, I should be able to get rid of the remaining numbers. Now, when I multiply with the three numbers, this is 1, 2, 3, that is 5 to 4 decimal, and so on. Now, observe that in the first one, let me write A, B, C. In A, in the first one, after the decimal, we have different numbers. In B, after the decimal, there is 0.24 and so on, which is not relatable with any of the above A, C, or D.
Only
But
C.
when you
Only,
look at C and D, after this decimal, all the numbers are same. So we will
Mhm.
be able to get rid of these numbers because after the decimal, both are same.
Mhm.
So if I subtract these two, 1000x minus 100x, which gives me 900x. On the opposite side, this is 524 decimal repeating fours. And for 100x, this is 52 point repeating fours. So those repeating fours, we get rid of those. And 524 minus 52 is 472.
And the 4 is gone. Oh, because of
And all those repeating fours are gone. So 472 by 900 divided by 900, and cancellation leads us to 118 over 225.
okay.
Exercise 9.5. Copy and complete each of the following by filling in the boxes with the correct number or symbol. So x is given, and what would be 10x?
It would be 6.66666.
Correct. 6 point. May I write 6.6 and that dot? So this is again 6.6 dot. And when we subtract these two, I'm left with 9x on left hand side, and I'm left with only 6 on right hand side. So 9x is equal to 6x. 9x equals 6 and x is equals to 6 by 9. Two by 3. Let's say this part, yeah, we subtracted. This was 6, this was 9. And when 9 goes on the other side, 6 by 9 or 2 by 3, which gives you 0.66 reoccurring. Try this B part.
17 over 99.
17 over 99. That's right. Write each of the following recurring decimals as fractions in its lowest term. So this first one would be 5 by 9, right?
Mhm.
And second one would be,
1 by 9.
that's right, 1 by 9. Third one,
8 by 9.
8 by 9. D part,
24 by 99.
24 by 99. And let's see, because this is divided by 3. So finally it is 8 by 33 in its lowest term.
Mhm. Six,
Next one
61 by 99.
is not divided by 3, stays as it is.
32 by 99.
32 by 99 stays as it is. Yeah. G part,
Does this one say that all 3 of them repeat or only 6 and 8 repeat?
all three.
Okay. So
It starts
608.
with 6 and it ends at 8.
Okay. So 618 over 999.
Correct. 618 over 999, and it equals 206 by triple three in the lowest term. H part.
233 over 999.
And just checked, stays as it is. Okay, try M part.
243 over 99.
Correct. 243 by 99 is 27 by 11.
Mhm. And then n?
Okay, let's try that.
3,102 over 999.
Correct. And it simplifies to 1034 by 333.
Mhm.
Now let's try these addition ones. P 5.4, that is repeating,
Uh,
and next is 4.5, which is repeating.
we have to first turn them into fractions and then add them, right?
We
Like,
can do it both ways.
oh, yeah, okay. Okay.
Uh, try decimals. Yeah, sorry. The requirement of the question is in fractions.
So for,
Yes.
is it best if we first add the recurring decimals together? Or like
Fraction is best. That
add them
will
and then,
avoid changing them into fraction first will avoid any mistake, any
Mhm.
rounding mistake.
But we already have 9.99999, so we can just go with that, right?
We can do that. Let's do it both ways.
90 over 9. Yep.
90 over 9. I'm changing it into fractions first. Let me do it as well. Forty-nine plus 41 is yes, 90 by 9 is equals to 10.
Can we just write 10 over 1?
Yeah, only 10 will do. When there's denominator equal to 1, no need to write that.
Okay.
Okay, question number 3. Write down the numerical value for each of the following.
0.1 for I.
0.1 and 0.01 and 0.001 and 0. Let me count these. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 9. So 1, 2, 3, 4, 5, 6, 7, 8, and ninth one is the digit. Comment on your answer to A. What is happening to the answer as the number of the digits in the subtracted number increases? What is the answer getting closer to? Obviously, when the number is increasing, the answer is decreasing and it is getting closer to 0. Now, whenever this type of question comes, we say it gets closer to 0, it approaches to 0, but we are not considering it 0 because in case we write 0.99 and we keep on writing it, there's no end to it.
Mm-hmm.
So we cannot comment that we will ever reach 0. So we'll be saying it approaches to 0 because we are not approaching to infinity in case of 0.9999 and so on.
So on the IGCSE, like questions like that will come on, not just like showing like the answer or something. He'll have to write it down as well.
Exactly, this type of question is not on the past paper,
Mm-hmm.
but this is concept building. For example, let me show you in differentiation.
Question?
When differentiation is a simple topic, when we will let's say we add 1 over x plus 3, and I say that x keeps on increasing up to infinity. So what happens when x is increasing? This is 1 over 1, then 1 by 2, 1 by 3, 1 by 4. This overall fraction keeps on decreasing. And the question would say what will be the maximum value of y when x keeps on increasing. So maximum value of y could be 3 because this fraction keeps on decreasing and approaches 0,
Mm-hmm.
like 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, and so on. And if it says what is the least value of
Oh,
y,
yeah. If it
so
equals 0, then yeah, it would equal to 3.
again in negative side, we cannot really comment where it will reach. Suppose 1 by minus 1 is minus 1 plus 3 gives you 2. 1 by minus 2, now it is again decreasing. That would be negative 0.5 plus 3 is 2.5.
Mm-hmm.
And negative 0.33 should give you 2.7. It is again increasing. So basically that's a curve and we get one of the lowest value. So highest possible value in this case is 3. C part says use algebra to express this and this as fraction in their simplest form.
So
So point six,
we just have to get the answer. Yeah.
yeah, 2 by 3 and that's 2 by 9. Express point 0.6 and point 0.2 as recurring decimal. So we already have these numbers. 6 by 9 plus 2 by 9 is 8 by 9. And 8 by 9, if I'm using the calculator, that is 0.88 and so on. All of these are 8, so single 8 is enough. Use your answer to cease to express this as fraction in its lowest term. Already did it in the previous part. And 0.6 plus zero point 0.2 was 0.8 as recurring decimal. Did both of these unintentionally in the same part, like as fraction and as recurring decimal.
So 8/9.
Yeah. F part says now repeat part C, D, and E using the recurring decimal. So another question. Explain how your findings to part F relate to your answer part A and B. Okay, let's do it. We are making a comparison. So we're repeating C, D, and E. C was use algebra to express this in its simplest form. So we just add them. 0.4 plus 0.5 should give me 0.9 dot. And then D part was use algebra to find fractions in its simplest form. Fraction in its simplest form. Zero point 0.4 would be 4 by 9. Zero point 0.5 would be 5 by 9. And when I add these two, this becomes 0.99 and so on. And when we add those fractions, 4 by 9 plus 5 by 9 actually gives me 9 by 9. That is 1. They explain how your findings to part F relate to the answer in part A and B. Hmm. Okay. So we see when it is like zero point 0.9, so on, it is almost equal to 1.
Mm-hmm.
Because wherever we will round it off, that 9 makes it 10, 10, 10, 10, 10, and so on makes it 1.
So that's how it relates.
That's how it relates. Recurring 9 is almost 1, but recurring 8 is not 1.
Mm-hmm. So the difference.
Example, for example, if I have this 4.499 recurring, I could assume it is 4.5.
Mm-hmm.
Jessica's teacher asks a class to find the largest number that is smaller than 4.5. Now, this would make sense. Smaller than 4.5 could be 4.4. And if someone says 4.43, that is also possible. But closer to 4.5 is this one. And if someone says 4.49, this is even closer to 4.5. And if one keeps on increasing these nines, they're getting closer but are lesser than 4.5 as well. So this keeps on increasing and results as 4.49 recurring. And this repeating 9 is basically very much closer to zero point 0.5 rounded.
Yes.
Okay. First part, G1 says 4.4. Why is G1 not correct?
Because it's not the highest.
It is not the highest. So largest number smaller than 4.5 is basically so Jessica Ransfeld now suggests that the answer is this. Still, it is not the answer because we can keep on adding nines. So recurring number would be the final correct suggestion. Why is it not correct? Because still not the highest number. Then Jessica suggests 4.49. Yes, we don't have any higher number than that.
So the full reason would be because it's the highest.
It is the highest. 9 keeps on repeating. No next student would be able to add a 9 to it
Mm.
because it is already repeating. So is Jessica correct? Yes, give full reason for your answer, including any algebra. So algebra would be that fraction.
Yeah.
And I would just agree with Jessica.
Mm.
That's a good answer.
Do we have to turn it
Or
into a fraction, or can we just leave it as it
we
is?
can we can do it. And that depends on our explanation. Like one is the math part, the other is a statement which we will use.
Okay,
So they should complement each other. Say whether each number is rational or irrational.
that's rational.
So first number rational, second,
Rational. Rational. And then yes, rational.
good.
irrational,
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 good,
rational, and rational,
good,
rational,
very good.
rational.
I think we should find irrationals only.
Yeah. So it'll be O is irrational, M is irrational,
O is rational, N is irrational, right?
and then M is irrational,
Irrational,
and then P is irrational.
that's irrational. And all other are
Rational.
rational numbers. Show that the following numbers are rational.
Well, they can
Okay.
be expressed as like a fraction
Yes, they could be expressed as fraction. Why did we write this as irrational?
because it's
This could also be written as fraction.
mm-hmm.
This is 4, 5 is repeating. I'm writing 100x is equals to 945.45 and so on. And if I write x, that is 9.45 and so on. So 99x is equals to 945 minus 9 gives me 936.
So it's
X is equal to, that's rational
mhm.
and makes it 104 by 11. This is rational. Could be written as fraction. Show that the following numbers are rational. So if we're saying they are rational, we have to write fractions for each of these. This is already the whole number. Again, mixed number is also rational. 19 by 8. And for 1.12 and so on, we convert them into
Yeah, just by 100 or by
fractions.
1,000. Yeah.
So 100 would be 112 and x only minus 1, that is 111 by 99. So this is 111 by 99, which makes it 37 by 33.
Triple one.
Yeah, I
So
can show you the working.
mhm.
If you multiply it with 100 for 1.12, 100x would look like 112.12 repeating,
Mhm.
and x only would look like 1.12 repeating.
Yeah.
After the decimal, both are same. So 99x is equal to 112 minus 1 is 111. So 111 by 99 and x is equal to 37 by 33. So we'll do the same for remaining numbers.
E is the simplest. It's just 427 over 1,000.
That's right.
And then can it be simplified? I don't think so.
No, that's an odd number. That's even number. And 427 goes with 3000, never goes with 3. No, no
Yeah.
simplification. Now what I'm actually doing is I'm checking all the numbers with the calculator.
Mhm.
We have calculator with us in every paper, but this exercise requires showing of all the working. So I've just checked that 427 never goes with that. Just look at the C part. I can say because I checked it with the calculator, but I never missed a working. 3 times is 37 and 3 times is 33. So that's not actually me. That's this machine. Examiner would say show all the working. Solve without using calculator, but we'll still cross check. That will save a lot of time. Now, if I'm doing it without calculator 427, I might take 2 to 3 minutes to think over it. But when I just wrote 427 by 1000, and this clearly shows me the answer, and it is the same, not changing.
So even on the questions where they say don't use the calculator, we could still use it to like just
We'll
check
use it here.
over. Okay.
That means do not skip any type of working. Anyone who's checking, would be able to second you that yes, the student is showing all the working and they're not doing it directly.
Mm-hmm.
Find a number in the interval -1 to 3 so that x is a rational number. Any number between -1 to 3.
0,
Okay. X is a real number but not rational.
1.
1 is rational.
Oh, not rational. 3/9.
You're already stating a fraction.
But it repeats. Wait, no, it's a recurring one.
Yeah, and it is possible to write it as a fraction.
Mm-hmm.
So one would be thinking that whatever number we write, we are obviously able to write it. And if I'm telling a number, I'm obviously able to write it. How can that number be not rational? When we come back to the definition, what were irrational numbers? Pi and
Squares.
squares which are not perfect. Square
Square,
roots which are not perfect.
so square root of 2?
Square root of 2. Now you cannot write this number as decimal or as fraction
Mm-hmm.
in its exact form. C part, x is an integer,
1,
right? X is a neutral number,
2.
natural number. So any number, yeah, like 0, 1, 2, any of these numbers. Fourth says, which set do you think has more members, rational numbers or irrational numbers?
I think rational numbers.
And why? Answer, I think, is correct. And why?
Because they're able to be like repeated, and there's also decimals in it and fractions as well. And irrational numbers, it doesn't. It's more limited, the choices that you
Mm,
have.
And what if I say, if we just write all the numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's right. I'm just trying to put some square roots over these numbers. So non-perfect squares are giving me, other than this 4, that's a perfect square. Other than this one, that will give me a perfect square, are giving me irrational numbers. And yes, you're right.
Also, we can also square the decimals as well,
Yes.
and the fractions. So would that like make them more so equal?
They won't be equal, but they still would be fractions. Like if I write 1 by 3 and then I write the square of it, this is 1 over 9. They're
Because
not equal.
yeah.
Like 1 by 3 is not equal to 1 by 3 square,
Mhm.
but that definitely is a rational number.
No, whatever is rational, we can still square root it and make it irrational, except for the numbers that work with
No, 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 no. It has to be a perfect square. For example, rational number is 7 a rational number?
it's a rational number.
We cannot take the root and keep it as rational. Square root 7 now is
It's
irrational.
irrational. See, that's
Yeah.
what I mean. That's what I mean. I'm saying, so if we can square almost all, I mean, like square root almost all of the rational numbers, would that mean there's still more irrational numbers?
Yes. It
Okay.
makes sense.
But
I was trying to do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But why did I stop? For example, if I put square root on all of these, I will get irrational numbers for non-perfect squares. Let me say they are out of these, we skip this 1, we skip this 4, we skip this 9. So out of these, they are 7. Irrational are 7. But still, all
They're
these 10 are rational. Rational are more.
irrational or more.
So mathematicians also talk about imaginary numbers, find out what these are and give one example. Okay.
I remember
So
pi
basically,
being an imaginary number.
imaginary numbers are known as complex numbers.
Mm-hmm.
Let me show you.
It's a joke.
So imaginary numbers are complex numbers which are negative numbers below the root. That actually means they do not exist. Any number on the number line is not imaginary. If this is a number line, this is zero, it goes on right, it goes on left. So I can cut it anywhere that is possible and I can write that number that is possible. So these are real numbers and imaginary numbers are those which are not on the number line. And simplest form is square root and negative number below that.
Okay. Infinity would be a real number, right?
That would be a real number.
Mm.
And for example, we will study graphs at a stage and we'll come back to this again. For example, I draw a straight line. This straight line cuts the x-axis at one point.
Mm-hmm.
This is the solution. Now, if I draw a curve, it cuts at two different points. So it has two solutions. One, this value of x, the other is this. Now I draw a cubic graph and I have three different solutions. Now, new case. For the first one, for the straight line, it can never be that I would have zero solutions. I'm changing that line, I'm raising it up. Is this possible if I raise it up?
Yes.
But it still
Which
intersects at a
one?
point.
Yeah.
And when I raise this up, there are two different possibilities. One, that it is not just touching at one point. If
Mm.
you raise that curve up, that would be tangent with the given axis. And second possibility is that you raise it enough that there are zero solutions.
That
So
makes
this
sense.
is complex.
Yeah. So it doesn't exist.
It doesn't exist. That is imaginary. We will study that under the topic of complex numbers.
Oh, and also
And
when,
for
like lines intersect with each other, and if they're like parallel, then also make it like complex as well.
whenever we are discussing imaginary numbers, we are discussing intersection with x-axis only.
Okay.
And in case of parallel lines, that is a different concept. They do not intersect.
Mhm.
For example, I draw one more line here. Let me call that line 1 and line 2. Now, line 1 and line 2 are not intersecting with each other, but they do have a solution with the x-axis. So when we are talking about imaginary numbers, where our concern is if they intersect with the x-axis.
So if there was like an equation for both lines, and it's asking us when do they intersect, but they're parallel lines. So would that make
Let's say this is y is equals to 2x plus 3. And let's say that is y is equals to 2x minus 7. So we can clearly see that both of the lines have gradient equals to 2. They
Mm-hmm.
will never intersect.
Mm-hmm.
So yes, when we will solve them, we will not get any answer and we will say it is imaginary.
Okay. So we can say,
And the third one, if we raise that cubic graph, this is the only possibility. I will always have one answer. And if you just sync that graph enough, still we'll have one intersection. And for the quadratic part, we also have sad face. So we drop them down, and this is the possibility,
Okay.
and one tangent is the possibility.
So out of all of these, only one is complex, the one that's not touching the x or the y.
That does not touch.
Mhm.
So linear always gives you at least one answer. Cubic always gives you at least one answer. So only the quadratic, only the single curve, there we have the possibility that it will give us the complex or imaginary roots.
Mm-hmm.
When we will use the formula minus b equals minus b plus minus square root b square minus 4ac over 2a, the quadratic formula. Do you remember it?
Yes, it was like minus b plus or minus.
Yeah.
Yeah, and then squared b squared minus 4ac over.
Whenever we will get this value as negative,
Mhm.
then we will say these are imaginary roots. That means the quadratic curve is not touching the x-axis.
Okay. So in the IGCSE, would any of those like come up?
Yeah, the quadratic one.
No, I'm talking about like being negative on the inside. Would there
Yes,
be
yes,
questions about it?
yes, there will be.
Okay.
That's a very easy topic. Complex numbers.
Mhm.
Sometimes the question is of this nature that show that there is no solution.
Oh,
And we will p square minus 4ac when it is negative, and we'll say there is no solution.
okay.
Like if we just draw the graph, that would take us 20 to 25 minutes. And if we do not go for the sketching or drawing, and we just check for b square minus 4ac, we can still say that there is no solution.
So we just have to show them the actual equation. Okay.
Yes. Okay. Um, we'll start from here tomorrow. And any other question you would like to ask, and I'll share this exercise with you. This is the one which we started before we practiced some SAT questions, sets and Venn diagram. Okay. This
Okay.
is very basic. So I'll share so you have a quick recap of that. And inshallah, we'll complete this topic tomorrow.
So,
Anything you would like to ask?
no, I'm okay.
And if I may ask, what topics are you studying at school?
Right now, we're just finishing up like, like I said, combining like terms and like equations and stuff, like rearranging equations.
Algebra.
Yeah. But our teacher is also moving on to more like linear kind of like on a graph and stuff. Like the equation of a line and everything.
You know this, that we always have an option. You can bring up any topic and we can discuss it, right?
Mhm.
We are doing the sets and patterns, but I'll share that with you again. We are ahead of our plan.
Mhm.
If I planned that for 7 classes, we have done it in 4 classes. Because your response was good, homework was done, and you're punctual. So anytime you feel like you need some help for any topic at school, you can bring that up. You can bring up the worksheet, you can bring up the question, the topic, and so on.
Okay.
And that's a very good topic. Maybe your topic is going to lead towards uh, geometry, coordinate geometry,
Mm-hmm.
gradients, parallel lines, perpendicular lines, equation of line, variation in lines by changing any value or variable. So you're more than welcome at any time. Mm. So far, we've been discussing patterns. Now we will discuss sets. We've already discussed few symbols. Let's quickly go over it. In case of sets, we have them defined first. They are enclosed by curly brackets and they're separated by commas. These are called elements inside these brackets. These are elements. And when we use small n, we just count them.
Small m?
N, nest.
Small numbers?
Small n, suppose n, A intersection B. So this n would mean counting.
Oh, okay.
Symbol for empty set. There are two ways we can represent empty set. Empty set could be written as empty curly brackets or like this. We can call it empty set or we can call it null set. Both mean the same. This symbol means belongs to. And if we write like this, it would mean does not belong.
So in a set, like, is it used to put like certain information in a set? Like this, like the E kind of shape means that it belongs in the set?
Yeah. Like it would be written as suppose X belongs to A. And A would be something which is already defined.
Okay.
Let me take an example. So let's say we write few letters. First of all, universal. And let's say universal is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So this is universal. Now let me say A is multiples of 3. The 3, 6, 9, 12, 15. Let's say B is multiples of 2. So 2, 4, 6, 8, 10, 12, 14. Let's say C is prime numbers. So 2, 3, 5, 7, 11, 13. Now, if I say, uh, let me say 7. I can say 7 belongs to C.
Yes.
Obviously, everything is from the universal set, but if we have to define something, we can do that. 7 belongs to C. If I say write down the numbers, write all the numbers, or I may say write two numbers. And which numbers are we asking? Write all the numbers that X such that X does not belong to, should have written E first. X does not belong to B. Now we already know what belongs to B. So does not belongs to B would be
All the odd numbers in the
all the
universe.
odd.
So
Yes. And we write them within the brackets. So if I say write, mm, if I say D X is such that X is greater than 15. Now, what would set D contain?
Well, 16, 17.
But
Oh,
can we
it's
write
just
that?
nothing. It's an empty set.
Yeah,
So it's with an element of
because that's outside the universal set. So we cannot write it. So D is an empty set, or we write it like this, a null set. So basically these are the symbols for empty or null set. And this is the symbol for does not belong. And this is the symbol for belongs to.
So those ones are only used when there's like multiple sets that you can compare, or like
Now, I
two.
just took an example. It could be anything. It could be name of days. It could be anything. But whatever it will be, the sets will always be defined.
Mhm.
We first of all have universal, then we have few sets defined, and then we have the questions.
Okay.
Okay, if we are talking about these two sets, some of the sets have number of elements that can be counted. They are known as finite set. If there is no limit to the number of members a set, then that is infinite. For example, set A is letters of alphabets. See, it is always defined. So we know what it would be, A, B, C, D, all the way up to Z. And it has 26 members. So that's finite set. In case of B, if we say positive integers,
Then it's
integers are whole numbers. So we start with 1, 2, 3, 4, and so on, and is infinite. Summary, sets are listed inside curly brackets. The symbol means an empty set. A, this next symbol means belongs to, or means A is an element of set B. And A dash B means A is not an element of set B. And at the end, N, the small n means is the number of elements in set A.
Mm-hmm. So for example, if it was number of A, but A was listing like the days of the week, so would that be like empty?
No, the number actually means the count.
Oh, so it'd be 7.
Yeah.
Okay.
Exercise 9.7, applying your skills. List of the elements of each set. Number A says days of weeks.
Monday, Tuesday, Wednesday, Thursday, Friday,
Right.
Saturday, Sunday.
We'll write all those 7. Then B part says month of the year.
Oh, January, February, March, April, May, June, July, August, September, October, November, December.
C part, factors of 36.
1, 2, 3, 4, 6, 9, 18, no, 12, and then 18. Yeah.
And last 36 also. Sometimes writing it this way also helps. Like when you thought of 1, obviously 1 into 36. So the other factor is 36 and 2 into 18. So if you're thinking about 2, the other is 18. If you're thinking about 3, the other is 12. Then we can write it in order.
So immediately connecting them.
Yeah. D part, colors of the rainbow. Do you remember
Oh,
it?
yellow, green, Indigo,
Like,
violet.
remember them in order.
Oh, no, not in order. Red,
That's
orange,
Roy,
yellow.
G, Bib. Or in the reverse order, Vibgyor, Vibgyor. In this case, the order would not matter, but we need to write all these colors and separated with commas.
Mhm. So is it
Even
okay?
for the say part days of a week, order is not a problem or the requirement.
So can we just write it like M instead of like Monday in the set?
Uh, Basically, in exam, you'll have like one or two of these questions. It won't be that much. And when I'm looking at the screen, I'm looking at more than like 25 questions. So sometimes we are a little lazy, but we should write it incomplete.
Okay.
So if we are writing about the months, we should write the full name, full letters, all the spellings.
There will be enough space,
Yeah,
right? There will be more enough space, yeah.
always. List all of the elements in set, multiples of 7 less than 50.
7, 14, 21. Can I just quickly write all of these down?
Yeah, sure. I like the questions.
No, no, no. Like, yeah, the answer.
Yeah,
And
sure.
then after, I'll write the two. Yeah, that's it. So 7, 14, 21, 28, 35, 42, and 49.
Good. Primes less than 30.
2, 3, 5, 7, 11, 13, 17, 19, 23, and then 29. Yeah.
Correct. G part. Ways of arranging the letters in the word toy.
Toy.
Yeah.
Oy.
So how many ways?
Oh, how many? 4?
We'll list them. We'll rearrange it and we'll write it. 6. You see, first one is T, then OY. Keep T over there and switch OY. Then make another letter first. Let's say T. O is the first one. Now we keep O there and switch the other two. Now you keep Y in front and write the remaining two and then switch the other two. And how will we write this in exam? TOY, comma, and TYO, comma. All these 6 separated with commas and
Yeah.
brackets at the end. Okay, find 2 more members of each set. Okay, I was talking about the C part. Why these type of questions are not there in exam? Because not everyone would know what these are. Like
Oh,
London is the capital of England, I guess, then France, and then I don't know what this is, Stockholm. And again, which countries these are. So, can you hear me?
yes, I can.
Part 369, what the next two numbers would be?
Sorry. Oh, 12, 15, 18.
Question number 3A. It says describe each set fully in words. So when we look at the first one, this is 1, 4, 9, 16, 25. What do you think this is?
Those are square numbers.
Those are numbers, and there's a specific pattern,
Yes, square numbers.
square numbers. So we can write, there are two ways to write. He says in words, square numbers, or if we write in set notation, I would write x is such that x is equals to n square.
Mhm.
B says Asia, Europe, Africa.
Continents? No. Yeah, continents.
C part 2468.
Even numbers?
Even numbers in it is specific, more specific.
Even numbers above zero.
Or let me say positive even numbers less than 8.
Hmm.
D part 2468.
Positive even numbers.
E part 1, 2, 3, 4, 6, 12. Observe and see what this is. I'll give you a hint. Factors
Factors of 12?
of 12.
Oh,
Number 4. True or false? If A is 1, 2, 3, 4, 5, may I say 3 does not belong to A?
no, false.
False. If B is primes less than 10, then NB equals 4. Now I'll have to check this first. Primes less than 10. 2, 3,
Yes.
5, 7. True. C part. Regular quadrilaterals. You know what quadrilaterals are? Four-sided
Four-sided,
figure. And regular mean
like all sides are the same.
all sides and all angles are same. So that would be a square.
Yes, it belongs in
And
it. So
it's true. If D is equals to paint primary colors, then yellow. Okay, now this is again like only those students who've studied colors or basic colors in physics would be able to answer this. So this question won't appear in exam.
Mhm.
E part. Square numbers less than 100. Then 64 belongs to E or not.
It does, true.
It belongs to E. That is 8 square. Question number 5. Make 7 copies of the Venn diagram and shade the following sets. Okay, let's do it. This is a good exercise.
So we just have to place it on there?
Yeah, we'll do it. Just let me just try it. This is first, second, third. Set A, set B, set C, and then we have a rectangle which is universal set. Now we are going to draw these 7. Let me write them for once. So we don't have to switch back. A union B. B is A union B union C. C D E F G. C is A union B complement. D is A intersection B union C. E is A union B and intersection with C is A union B intersection C complement, and G is intersection C union with A intersection B. Okay.
What does complement mean?
Complement would mean except that, other than that.
Oh,
Like B complement would mean not B.
okay. So A is
Okay,
union.
so first we have A union B. We have 3 sets A, this is B, and this is C. And we take this rectangle as universal set. So A union A and B combined Do you agree that this, do you agree with this?
Yes.
B part. That was A. B part says A union B union C. Now we are combining A, B, and C, all three. This
We
is
should.
A, this is B, this is C, A, B, C. So we shade all these three. C is A union B complement.
Oh,
A
so it's not including A.
union B
Wait, it's not
complement.
including B.
That means B is not included, and anything which is not included other than B is union with A.
So it's A and
This
C
is
shade.
A, this is B, this is C, B, C. Now I'm just marking which is B complement. This, second, third, fourth. This is B complement. And I
Mm-hmm.
have to make union of A with this. May I mark A in red? This, second, third, these are A. So if
Yes.
I just combine these two, red and green. So
But
this
isn't
is something which I'm getting.
but
Complete
isn't the
A,
middle part of it also
part
part
of
of
C. Say that again.
isn't the middle part of it also part of B? Like for the A and B?
That is part of B. But we have to understand this, that it is also part of A, and we are adding A with the complement of B. Uh, I'll explain it in one more way.
So if it was just
So
B
this was
complement,
the
yeah.
shading. I'll explain. Yeah, if it was just B complement, we'll leave B out and shade everything else. I'll explain. You'll understand this way. Two, and the third one, C. This is A, this is B, this is C. Let me just number them. If this is
Okay.
one, two, three, 4, 5, 6, 7, and 8. So if I can write B complement, that would be anything but not B. Do we agree that this is 1, 4, 7, and 8 B complement?
Yes.
And we talk about A. Is it 1, 2, 4, and 5?
Mhm.
So we already have B complement, and if we use one of these two, A union B complement, that means I'm looking at 1, 2, 4, 7, 5, and 8.
Mm-hmm.
So now when I go for shading, I am shading this 1, then 2, then 4, then 7, and that's a 5, lastly 8. So only 3 and 6 are missing. 3 was
That's
this
part of
part,
Mhm.
and 6 was this part. So only 3 and 6 are missing. Everything else is shaded.
Mhm.
Got it?
Yes.
This numbered technique always works. Once you practice a little, you'll be able to do without these numbers. The D part. A intersection B union C.
Can I be back in 2 seconds?
Sure.
Okay, sorry.
No issues. So this is A, this is B, this is C, and we are dealing with this given notation. A intersection B union C. Now, always go for the brackets first. So B union C. Would that mean all of these parts?
Yes.
Now we know if it was only B union C, we'll shade these parts marked in green.
Mm-hmm.
And when we are talking about intersection of A with this section, intersection of A, now we are talking about the common So what is common with A are these parts only. So
Mm-hmm.
whatever was B union C on one side, intersection of that three regions.
Sorry, could you repeat because you froze?
Yeah. Intersection of marked tick mark in green are B union C.
Yeah, you froze again.
Actually, weather
Should I
today
off my
is not
camera?
stable here.
Okay.
Yeah,
Okay.
it shows on my side that internet is unstable.
Okay.
Maybe this will work better. These were B union C. And now we have these two tick marks are overlapping each other. Clear?
Mm-hmm. Mm-hmm.
Should I move on the next one?
From what I heard, it was just that A intersects with it, but I still don't understand why we don't have to do like the middle part. Just the part where A is a common with it.
Yeah, yeah. We'll do it in another way as well.
Okay.
This is A, this is B, this is C. Quickly number 8. Now C, B union C. I'm combining all these B union C. So we see this is 2, 3, 5, 6, 4, and 7. So I highlighted 2, 3, 5, 6, 4, and 7.
Mm-hmm.
Now we are writing A only. And that is 1, 2, 4, 5. Now when we talk about intersection of these two, A intersection B union C. So what do you see? What is common in both of these?
Two,
Is it
four,
2?
yes. 4 and 5.
Then we have 5 and 4. So 2, 4, and 5. That's why we shade this part only.
Okay.
Third way could have been this. Similar to the first one, we were doing A intersection B union C. So this is A, this is B, this is C. Now first B union C. If I just mark these with black, this is B union C. Now A only. If I mark A in green, now I know what A is marked in green. I know what B union C is marked in black. And we are section. So we see where we find the two tick marks, green and black. It is in this region only. This is in
Hmm.
common region. This is a lone region, and these three are alone regions.
Just a common between them.
Clear?
Yes.
The E part, A union B intersection C.
So it's just basically the same thing.
A
Just
B
we
C.
have to pick
Now
a
this is
common.
so can we shade it directly? Just keep in your mind what A union B is without shading, without writing, and then which part of it overlaps with C is
Yes.
this part. F part A, B, C, A, B, C. And let's see what we have to shade. F part is A union, B intersection C complement. A union with B intersection C complement. Now just keep in mind what B intersection C is. Do you agree it is this part?
Yes.
B intersection C. Now this complement says everything except this. Everything except this. So we would know that B intersection C complement is 1, 2, 3, 4, 5, 6. These six parts, right?
Yes.
Now we make a union of all these parts with A.
So it's
And
just
in
the
union,
three.
we add them up.
Yeah.
So we are just leaving this part behind and shading everything else.
Why don't we just shade A?
We are shading A.
I know, but why don't we just shade A?
Just shade A. Okay. Because we are making a union. We're combining A with whatever this is.
Hmm.
Union. We are combining A with whatever the other section is.
Not intersecting. If it was intersecting, then it would just be A.
Then just the A. And if it was not in like union, this would have been intersection.
Mm-hmm.
We can do it with numbers as well. Do you want that?
Sure.
Okay. This is A. This is B. This is C. 1, 2, 3, 4, 5, 6, 7, and 8 sections. Now B intersection C complement. So we can see intersection part is clearly 5 and 6. B intersection C is 5 and 6. So complement is everything except 5 and 6. 1, 2, 3, 4. We skip 5, we skip 6, 7, and 8. Now we are writing A, which is 1, 2, 4, and 5. Lastly, because of this union of these two, we add them up. A union B intersection C complement. So when we sum them up, I can see 1, 2, 3, 4, 5. I cannot see 6, then 7 and 8. So we are leaving only 6 behind. We are leaving this 6 and we are shading everything else. Got it?
Yes.
Last. G is A intersection C union A intersection B. A intersection C union A intersection B. A intersection C union A intersection B. A, B, this is C. Now, first, A intersection C marked in red.
Mm-hmm.
A intersection B, I'm writing this, marking it in green. Now we have these two. This says combine them. So
So
when
we
we
just shade
combine
all the
all of
ones with
these,
check mark.
yeah. So this is the shaded part. Question 6. In a class of 30 students, 22 like classical music and 12 like jazz. 5 like neither. Using one diagram, find out how many students like both classical and jazz. So first of all, we are looking at two different options. So we'll draw only two circles. First one, the second one. And the options were classical and jazz. Let me label the C and J. And we have a universal set. The symbol of universal that is equal to 30. Now I'm not writing this 22 anywhere. This is classical music because, for example, I cannot write 22 here because I know this complete circle is going to be 22. So I just keep it in mind that C total is 22 and J total is 12. But I'm very sure what this 5 means. So I'm writing this 5 here. So what I can write is 22. And if this is X, I can write 22 minus X. Any objection in this writing pattern?
Yes.
And on the other side, I can write 12 minus X.
Mine.
Do we agree?
Yes.
And now we are going to find out how many students like both. So that is clearly X. Add these. This is number 1, 22 minus X. Then I add the second one, that is X. Then I add the third one, that is 12 minus X. Then I add this last fourth one, that is 5. And when we add all these four, equal 30. So negative x, positive x, 20 plus 12 is 34 plus 5 minus x equals x. So x equals to 9. So there are 9 students who like both jazz and classical music.
Sorry, could you repeat because you froze?
I said we tease and I'm writing these four. First section, then the second section, then the third section, then the fourth section, and all of these should equal 30.
Yes.
And when we solve for x, it comes out to be 9. Can you try question number 7?
Sorry. Only two of the x's cancel. Yeah, because one is negative, one is
Yes.
positive. Yeah.
Is negative x and positive x.
Yeah. Mhm.
Yes, we can cancel that. And the third one, x is negative. At the end, I took that x on right hand side and brought all the numbers on left hand side. You can do it either way, you'll get positive 9.
Did you redraw it from like the second step?
Yeah, sure. Redoing it from the second step. Now, if you can see negative x and positive x cancels out, this is 22 plus 12 minus x, t numbers 34. 34 plus 5 is 39 equals 30. 39 minus is equal to 6.
How did we remove the brackets from 12 minus x?
That's simple. Just like this. 22 minus x. I was just writing these brackets to show you clearly which sections I'm adding. Second section plus third section plus the fourth section. There's no need if you don't want to write
Oh,
these brackets, you can. So open these brackets 22 minus x plus 12 minus x plus 5 is equals to 30. So positive and negative x cancels out. Now 1, 2, and 3 numbers. 39 minus x is equals to 30. 39 minus 30 is equals to x. X is equals to 39.
okay. So afterwards, 39?
That was the required question. 9 only.
Yeah.
It says how many students like both. So we say 9. If he would have asked how many students like classical only, then we will say 22 minus 9. If the question would say jazz only, then we'll say 12 minus 9.
Where does 39 come from?
Where's 39 coming from? Addition of these three numbers.
No. I mean, in the end, it was x equals to 39.
No, x is equals to 39 minus 30. This 30 is coming from the universal set.
Okay.
When you
On the other
when you add
paper,
these,
I think it's a
sorry,
mistake. And the other, like when they're writing, I think it's a mistake. But it's okay. It's just 9. X equals to 9. Okay.
9 is the intersection part. What I
Yeah.
would write is this is 13, this is 9, this is 3, this is 5, and all of these would add up to 30. This is classical. So in
Yeah.
classical, there are 39, there are 13 plus 9, which is 22. And in jazz, there are 9 plus 3, which is 12, and neither, that is 5, both, that is 9.
Which one are you solving right now?
The same question 6. I'm not solving it. We are just discussing it. If I, to make clarity, that 22 minus x would actually mean 13.
Because you just have to subtract it. Yeah.
Yes. Now let's try question number 7. As we are already discussing the complete set, the following set all have numbers of things in common. So M is 1, 2, 3, 4, 5, 6, 7, 8. N is 1, 5, 9. O is 4, 8, 21. So whatever the universal set is, these sets are from that universal set. All three are contained within the set of whole numbers. They are also contained in the set of integers less than 22. If we are defining these three, so they are whole numbers, they're less than 22. When dealing with sets, there is usually a largest set which contains all of these is known as the universal set. Complement, we've already solved some questions. Complement means except that. So if universal is this and set F is 246. So complement of F would be everything 246.
Except for that. So universal means everything. So does that include, so that's just whole numbers and integers less than, or like can everything be defined by something? Can it
Fine.
include like
It would be defined
fractions,
universal as well.
decimal?
It would be clearly defined. For example, I say set of even numbers. So universal is only 2, 4, 6, 8, 10, so on. And if I define set of even numbers less than 100,
Mhm.
every set would be defined.
So it's kind of like something that like other sets can compare to, or can be a part of.
Yes. For
Yeah.
example, let's say you are allowed to keep all the numbers or the universal set in your bag. And let me say a universal set is defined even numbers less than 100. So it has a limit. When I say everything, universal means everything. What is that everything? Whatever is defined. Now you would have 2, 4, 6, 8, 10, and up to 98. So you'll have this in your bag. Now everything would be taken out of this universal set. For example, we talk about factors of 12. For example, we say multiples of 17. So anything would be taken out of this. So if I say multiples of 17, so we know first multiple of 17 is actually 17, but that is not in universal set. So I'm not writing it. And 17 into 2 is 34. Now we know 17 times 3 is actually 51, but 51 is odd. So I'm not writing it. So 17 into 4 is 68. 17 times 5 is again an odd number, that is 85. So we skip it. And then 17 into 6 is 102, which is actually outside the universal set. So multiples of 17, when we pick them out of the universal set, are only 34 and 68.
Okay.
Basically,
So now
this rectangle is the universal set.
in
Rectangle.
questions, yeah. In questions, it would be like the first universal set, and then other sets would like be under it.
Will be under it.
Other questions
Would
would,
be
yeah.
subsets of the universal set.
Yeah. Okay.
Unions and intersections, we've discussed them, what they are. Now subsets. For example, we have,
Everything that is not an everything set is a subset.
yes,
Mm.
of the universal set.
Yeah.
For example, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we will discuss subset and proper subset. Let me write the symbols. Subset is this elongated C with a line under it. That is C with longer arms with a line under it, and proper subset is this only, no line under it.
Okay.
Okay, for example, we have this universal set and I'm writing few sets. A is 1, 2, 3, 4, 5. Then I write B, which is 2, 3, 4, 5, 6. Then we write C, that is 2, 3, 4, 5. Then I write E, which is 2, 3, 4, 5. And F, which is 1, 2, 3, 4. Now, if I say A, I'll explain what subset and proper subset is. If I write A is a proper subset of the universal set, would you agree?
Yes.
So I'll come back to universal again after I explain this.
Mm-hmm.
So let me say that, let me write one more. G is 1, 2, 3, 4, 5. May I say G is a subset of A?
Yes.
And when I write C is a proper subset of A. Now I'm explaining the difference.
Mm-hmm.
If I need to use set G, I can get all the elements from A as well. And if
Mm-hmm.
I need to use set C, I can use all the elements from set A. But notice that in set A, there are 5 elements. But in set C, there are 4 elements. L-
Yes.
Let us say that these are employees A, B, C, E, F, G, and they have their briefcase, and these are the tools inside their briefcase. So if G forgets his briefcase at home, he can take help from A.
Mm-hmm. But is it the same thing?
It is the same thing. And if C forgets his tools at home, he can use help from A. But if A forgets his briefcase at home, he cannot take help from C because A also needs one which is missing in C.
So you can only get help from G.
It can get help from G. So basically, A is also a subset of G because they are exactly equal to each other.
Oh, so improper, I mean, like Yes, just subsets are basically the same
which can help
sets
each other.
twice.
Yes.
Yeah. Oh,
And
okay.
proper subset is actually less than in number as well. For example, C is a proper subset of A because C can actually take help from A
Yeah.
and is also in less than size. And C is also a proper subset of B. He can exactly take help from B and is also smaller in size. Clear?
Yes, so yes. So proper subsets have to be like smaller than the normal, like the
Yes,
original
their
set.
number of elements are also lesser.
Mm-hmm. And they have to fit inside the set, basically. Like their
Yes.
elements have to be from that set. Oh, okay.
Yes, they should share the same elements, the smaller one, the subset one. And if they are also lesser in number size in number, they are known as proper subset. So if I talk
And
about this F part, if I talk about this F is basically a proper subset of A
yes.
because he can take help from A and is also smaller in size. So this is the main difference between subset and proper subset.
Mm-hmm.
Let's do one worked example. List the set of W union T. So we just combine both of these and write them in order without missing anything. Then W intersection T. So we would see only for common. I can see 4 in W, but there's no 4 in T. Then
8,
8, yes. No
20,
12, no 16, 20, yes.
and nothing
And
else.
24,
And
yes.
24.
So 8, 20, and 24.
Mm-hmm.
Now, is it true that T is proper subset of W? So let me hide this solution. So that would mean that T, if T forgets his elements at home, can he take
No,
help from W?
no.
No, because T would need 5 and there's
Mm-hmm.
no 5 in W. 8 is there, 20 is there, 24 is there, and 28 is also missing. So no, and even if he says is a subset of W, even then it is a no. I'll solve that question and share in WhatsApp. I just have one more class and after that I'll share it.
Okay.
Anything else other than that question?
No, I'm good.
Now, which questions are you talking about?
I think my dad sent like a picture of it.
Yeah,
Can you
I'll
show
open
me,
it.
can you show me the paper?
Yeah, yes, I can do that.
Oh yes, question 3. Question 3, A and B.
Okay. Mm, It says F are equilateral triangles and G are isosceles triangles. Explain why F is a subset of G. We know what isosceles triangles are,
Mm-hmm.
whom in which two
Two
sides are
sides.
equal. And we know what equilateral triangles are.
All sides.
One, three. Now I can say this is isosceles. That would be true. I can say this is isosceles. That is still true. Do you agree?
Yes. Mm-hmm. Because it has two
So
sides are
that,
equal.
yeah, two sides are equal. Even though it has one additional property, that is why we can also call it equilateral. So that is why equilateral triangles are a subset of Isosceles triangle.
Okay. And then B?
B part. What is F intersection G? Can you simplify F intersection G in any way? Okay, 3B with two or three sides. Same way. Same thing. Two or three sides equal. If we just try this out, for example, this is F and this is G. F has to be perfectly equilateral and G is isosceles, only two sides equal. So I have different examples. One of which is this. The other could be right angled triangle, but with equal sides. And F has to be three sides equal. So F intersection G. So explained in words that two of the sides are equal, although there is this third one as well. So it is isosceles and equilateral both.
So,
If I draw a triangle and write these sides, 7 centimeter, 7 centimeter, 7 centimeter. So I can say this is isosceles and I can say this is equilateral both.
mm-hmm. So that's why it's able to intersect.
That is why
Me-
it is overlapping each other.
Mm.
Like equilateral is always isosceles, but isosceles is not always equilateral.
Mm-hmm. So if we like simplified, the answer is just that equilateral is always isosceles, but
Yes.
isosceles not always equilateral. Okay.
And which question was the next one? I think you said two questions.
Yeah, I think it's more up. Question two. Question two.
Question two.
No, I don't. Can you move a
Okay.
little bit more up? I did that one. Oh no, it was question two. When it asked us to combine all of it, like there was one letter missing from it. Like it was a missing V. So I don't know why I was missing V.
It should not miss V in the answer space.
Yeah, and like in the marking questions, like the answers, it was missing V.
And that must have been a typo.
Oh, okay.
If you did it, that's right. In
Okay,
case of union, we do write everything.
okay. Then I don't have any more questions.
So in case question 7 is clear, we've talked about unions and intersections. We've talked about subsets. We just discussed these questions. And let's talk about a little about these shadings and these particular cases. I can see these rectangles with few circles. When I talk about this first one, may I say this is just the universal set.
Yes.
In the second one, it is a universal set which also represents a subset. A is a subset of universal set. And the third one, we are representing two sets. Obviously, it has to be always within the universal set, and they have nothing in common. That is why they're not touching or overlapping each other. In the fourth one, this is something which has an overlap. The shaded region would say that it contains elements which exist in set A and set B both. Then A union B would be shaded like this. Any objection?
No.
The sixth one says Venn diagram can also be used to show the number of elements in NA in a set in case M is number of students doing math as a number of students doing science. So for example, I say NM, what would be the answer?
13?
What about 17?
Oh, because
If
oh,
you're
okay.
standing at the door of the class
Mm-hmm.
and you ask the students to raise their hands who are taking math, So you'll see
Mm,
19 hands.
okay.
And if you repeat your question that who are taking only math and nothing else, you'll see 13 hands.
Mm. So I just had to add in the extra four from the comments. I thought it was just saying all of the math was 13. So
Yeah,
I didn't
all of the
count.
math in this case is 17.
Okay.
For science, it is 10. And for only science, it is 6.
Okay.
How many students are there who are taking both?
Four.
How many are there who are taking neither?
Seven.
7. Okay. A complement is shaded like this. A is left out, everything else is shaded. And then A union B, complement question. We did A union B, and when we complement that, when we left leave that out, we are left with everything else shaded. Uh, A is a subset of B, or I would rather say proper. A is a proper subset of B. That is why it lies inside B.
To be a proper subset, doesn't it like doesn't B also have to be a subset of A?
One would fit in the other, and the
Mm-hmm.
total number of elements are also less.
Isn't a proper subset that they have like equal?
Subset could be equal, but proper means equal and also smaller in size. A, B, C, D, E, and F. Let this be the first set, and let this be the second set. A, B, C. So B is a proper subset of A.
Mm-hmm.
One more for clarity. A, B, C, D, E. I will say C is a subset of A, or I can say A is a subset of C. In this case, we are not using the word proper.
Oh, I thought that's
If
Mhm.
B comes to office,
I
should go
thought
on
the
with your
sign
question.
for a proper one. I think I'm confusing. I thought the sign for a proper one was with like the line under it, and the proper ones were all, like equal. But yeah, it's flipped.
Okay, let's make it sure.
This is-
Yeah, with the line is
I know.
subset, without the line is proper.
Okay, I need to write it down again. I guess we really need to change the notes
I
of
should
it.
just learn it with a mnemonic that proper subset is shouting out that I don't need a line to prove myself.
Okay.
And subset only is supporting itself with a line.
So proper is equal or less
Yes.
elements. Okay.
We would say equal and less.
Equal and less?
Yes, for proper.
Okay. And then just the subset. Is it just less?
Yes. I'll try with another example. Maybe this would help. Okay. Now we're talking about a class where one teacher is there and there are many students. But for our example, we are considering these three people. And definitely when we are there for the class, we are considering that everyone is coming prepared with all the instruments they need. For example, today we have a laboratory lesson, and we were asked to bring some instruments. For example, student A forgets his bag at home. He can take help from student B because they're in the same class. They should have the same instruments. And same goes with B and A. So I can say that A is a subset of B, or I can say B is a subset of A because both of them can assist each other. They have same elements. But teacher may have some extra instruments.
How can
For ex- Go on,
A's
go.
like how can like A help B because it has no
Help me.
instrument?
For example, we are talking about a science experiment of chemistry experiment, and they were asked to bring few things. Let's say that was litmus paper, one thing,
Mhm.
matchbox, second thing, and a lighter would use, let's say, spirit. So student B should also have a litmus paper, a matchbox, and spirit. So if student B forgets his bag at home, he can take help from student A because they are in same class and they're attending the same laboratory. So they should have same instruments.
Mhm.
And if student A forgets his bag, he can take help from student B. But the teacher, when he or she is attending that class, would also have the litmus paper, the matchbox, and spirit. But the teacher may have to take another class at another time. So he may be equipped with few more extra things. So I can say student A is a proper subset of teacher. Student B is a proper subset of teacher, but A and B could be subsets of each other.
If A doesn't have any, then it can't be like a proper subset, right? I mean, it can't be a subset,
Yeah.
right?
Let's introduce one more student, student C. So if he has a litmus paper and a matchbox only, this is what you're saying. Now
Mm-hmm.
I can say C is actually a proper subset of A. C is a proper subset of B. C is a proper subset of T because C can actually take help from A, B, and T and is also lesser in size. A and
Oh,
B
okay.
can take help from each other, but were same in size.
Nothing is a subset of it.
Yeah, just like these two where we use alphabets. Look at this A and C. They can
Mhm.
take help from each other, but their size is same. So it is not proper. But when we talk about A and B, they B can take help from A and is also smaller in size.
Mhm.
But A cannot take help from B because A would need E and F also, D also, and B is not having that.
Okay.
Let's try this exercise. Or shall we go through the worked example first? I think we should go through the worked example first. Okay, universal set can be seen A, B, C, D, E, F, G, H, I, J, K. So whatever we do, we are selecting from these letters. Where A is A, C, E, H, and J. B is A, B, D, H, and G. A says illustrate these sets in a Venn diagram. So we're going to make a rectangle and two circles. One, two, this is A, this is B, this is universal. Now I'm looking at the universal set or say set A only, set A. And I can see that letter A in A and B both.
So it's in the middle.
It's in the middle. Then I see C, that is only in A. Then I see E. I'm looking at A only, this capital A only. E, that is not in B. Then we see H, and it appears in both of these sets. Then I see J, and I can count here as well that A has five elements, and there are five elements I can see. Now I'm looking at B. A is already written, B is there, D is there, G is there, and H is already written. Now we go through the universal set. A done, B is done, C is done, D is done, E is done, F is missing, so F should be outside both of these. G is written, H is written, I is missing, I should be outside. J is written and K is missing. And we can just count these to be sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total is same.
Mm.
Illustrating in Venn diagram is done.
When I
B
count
part
mine,
says list the element.
when I was also doing it, but when I count mine, I get 12. Wait, can I quickly recopy it down?
5, 6, 7, 8, 9, 10, 11. It has to be 11.
Can I quickly
Go
recopy
through
it?
it again. Maybe you written it twice. Yeah, sure. Make sure you're not counting the commas. It may look like I.
Okay. Okay.
So you have 11 now.
Mhm.
B says list the element of set A intersection B. And
A and
can you point
H.
them out?
A and H.
E and H. So we write them in curly brackets separated by commas. C part says find N A intersection B.
Two.
Sorry?
Two.
2, yes. D part says list the elements of set A union B.
A, B, C, D, E, G, H,
A,
J.
B, C, E, G, H, J. Right. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Very good. N A union B.
8.
8. Elements of A intersection B complement.
Then it's going to be a null set.
No.
Okay.
Just have a look at B only.
Mm-hmm.
Now you can make an imaginary circle around B.
Mm-hmm.
And when it says B complement, erase that from the face of the page.
Mm-hmm.
Now whatever is left is B complement. I can see 6 letters which are left after we erase B.
C, E, J, F, I, K.
Yeah, that is B complement. Anything it has common with A is the intersection part.
Mm-hmm.
And those are
The introduction part, but it's
okay.
also part
We
of
sh-
B?
Let me shade it.
Uh-huh.
Hmm, Let me
Middle
see
part.
the color. This one. When we say B complement, we are actually eliminating this section. It is not there.
Mhm.
Anything present after this is B complement. And if I have to shade B complement only, and what did I do? This was A, B. Okay. A, B, C, D, E, F, G, H, I, J. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I just erased one letter, which was that. A is there?
F.
Yes. Thank you. Yep. Thank you. So if I just look at B complement, or let me make another Venn diagram quickly. This is A, this is B. A, B. B complement is all of this other than B. Can you see anything common with A and this shaded region?
Yes, the middle
Is it
part.
this part?
A and the middle, what do you like
A
A?
and complement of B. A and complement of B. Complement of B was all shaded in blue, and then the common part with that of A is
Is
shaded.
A. Okay.
So this is C, E, and J.
So we just basically dissected the question.
Yes, we can
Yeah.
also do this. B complement, and we can write all the letters which are C, E, J, F, I, K. This is B complement, and then we have our A, C, E, J, A, H. And what is common both of them, A intersection B complement? That is C, E, J.
Mhm.
Use the Venn diagram to answer the following questions and list the elements of A and B.
6, 18, 12, 24, 4, 8, 16, 20.
So these are A and B is 4, 8, 12, 16, 20, and 24. These are A and B. And while we do this, either we do it with letters or numbers. We'll try to keep them in uh, order. List the elements of A union B.
Intersection?
Union.
Are we doing C? Okay. Uh, well, it's the same as before. Just
Sorry, sorry,
yeah.
sorry. I thought we did the first two parts. You're right. List the elements of A intersection B. B part, yes.
Maybe 12 and 24.
12 and 24. Now the C part.
It's the same thing as A. Well, if we keep
Same
it in,
thing as A, but no overwriting. Like if we look at A, I can see 12 in two places in A and B both. So I'm going to write them all, but no doubling, no overwriting. This is 4, 6, 12, 18. 4, 6, 12, 8 is also there. 4, 6, 8, 12, 16, 18, 20, 24. So I'm writing all of them in increasing order and no overlapping and no doubling.
okay.
Question 2. Use the given Venn diagram to answer the following questions. List the elements that belong to P and then Q.
A, B, C, D, E, F.
A, B, C, D, E, F. And
Q
part Q,
is E, F, G, H.
E, F, G, H. B part says list elements that belong to both P and Q.
A, B, C, D, E, F, G, H.
Both P and Q.
Mm-hmm. A, B, C, D, E, F, G, H. So is that intersection?
Intersection.
Oh, okay. Both belongs to it. Okay.
Yeah. Belongs to both of these. Uh,
Okay.
C. List the elements that belong to neither P nor Q.
I and J.
I and J.
P but not
Belongs to
Q.
P, but not Q.
Everything okay. A, B, C, D.
A, B, C, D. A, B, C, D. And do you agree that we can also call it P intersection Q complement?
Yeah.
Number three. Draw a Venn diagram to show Venn diagram to show the following sets and write each element in its correct space. Universal set A, B, C, D, E, F, G is given. A is defined. B is defined. So now let's draw our
Rectangle.
rectangle and those two circles. Universal set. One is A, the other is B, and slowly B, C, F, G. B is in both, C both, F both, and G comes here. When I look at B, this is A, B done, C done, D is there, and F is there. 1, 2, 3, 4, 5. 1, 2, 3, 4. And A, B, C, D, E, F, G, H.
8
This was
total, right?
8 total.
Okay.
B part says universal whole numbers from 20 to 36 inclusive. A is multiples of 4 and B is number greater than 29.
Yeah.
Okay. So another universal set. Set A, set B. So we start from 20 and we write multiples of 4 in A and B is anything which is greater than 29.
Up to which number? 36. Okay.
Now let's quickly match this. In A or say A only, this is 20, 24, and 28, and in the overlap is 32 and 36. Do we have it same?
Yes.
And then B only is 30, 31, 33, 34, and 35. And all the remaining numbers are outside A and B. Fourth number, the universal set is students in class. V is students who like volleyball. S is students who play soccer. There are 30 students in the class. I'm filling this information as I'm reading it. The Venn diagram shows number of students. Find the value of X. How can we do this? Way to try.
Is it 6 students?
Very good.
Just have to add it all together and subtract.
And equate it with 30. How many students like volleyball?
Uh, 16.
Very good. How many students in the class do not play soccer?
22. Oh yeah, we don't count the middle part
They do not.
because the middle part is also soccer. Okay. It's six. Yeah,
In whenever you
16.
face these type of questions, wording is the only thing that got me stuck as well in the last class. So 10 is volleyball only. X is both. 8 is soccer only. The last 6, because X is also 6, this is neither. 10 plus X is volleyball. X plus 8 is soccer.
Mhm.
So quickly, A, B, and let me label them with letters X, Y, Z, and P. So what is A?
A is 16.
No, this new one.
Oh, A is X.
And what is A only?
A only is X. Um,
Then A should be
X minus Y.
X and Y. Let me
X.
change them with numbers. Maybe that would be easier. 2, 3, 4, 5. May I say A is 5?
Yes, if you
A
add them together.
only is only A.
Only A is also 5. Is it?
On, only A has to be 2.
Okay. So it's just,
B
uh-huh. And then only B would be 4.
and B.
A and B,
Yep.
9. No, 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 no. 6.
Okay. Now clarity of words. When we talk about A, it is 2 plus 3, which is 5. When we
Mm,
say only A, that is 2. Nothing
mm,
else.
mm,
When we say B, this is 3 plus 4, 7. When we say only B, that is 4.
4.
When we say A union B complement, or we say neither, that is 5.
So
Or
saying,
we say A and B both is A intersection B. We
mm,
say 3.
Okay.
Copy and complete the diagram and shade the region which represents A intersection B complement. This is almost the third time we are facing this same question.
So it's just the A part, not including the middle
A
part.
intersection B label it with letters P, Q, R, S. So which one is going to be shaded? P, Q, R, S.
E.
Which one would be shaded? P, yes, that's right. Now, what is set builder notation? This is a specific way to write it. That is basically the explanation, the detail, what the set is about. So far, the contents of a set have either been given in a list of elements or described by rule in words that defines whether or not something is a member of set, a clearly defined set. Now, this is just the way, another way of writing, which is known as set builder notation. If we directly jump onto it, this is, it says X, where X are actually the elements of set A. And it says X is such that X is a natural number. For example, if I introduce another set, I would say X is such that X is a prime number.
Mm-hmm.
So it is clear. Nothing else is given. I don't have any upper or lower limit. And I would know that this should be 2, 3, 5, 7, 11, 13, but I don't know where to stop. So universal set will guide me where to stop and where to start. For
So
example,
it's
in the
all
previous,
so it's always X that we use?
it is X that we use.
Okay.
Okay. And it could be any sequence. So X is such that X is a natural number. And all the explanation where A is the set, all the values are X. This we read these double dots such that each value of X is a natural number. For example, for this B, it says X is a letter of X is such that X is a letter of the alphabets, X is a vowel. So we would know it is A, E, I, O, U. Another example, integers greater than 0 but less than 20. These are words. And what is set builder notation? This is set builder notation. Both mean the same thing, but different style of writing. X is such that X is an integer. It also says integer. It also says integer greater than 0, less than 20. Greater than 0, less than 20. Worked example. List the members of set C if C X belongs to primes and between 10 and 20. So all the prime numbers between 10 and 20.
Uh 11, 13, 17, 19.
11, 13, 17, 18, that's right. Express the following set in set builder notation. D is right angled triangle. So when we write X is such that
Yeah.
X has to
X
be a triangle.
is such that X is a right angle triangle. Yeah.
Yeah.
Do we have to write X is a triangle?
We just split it into two normally. One is we explain what X is, then we define it, the limits.
Okay.
We'll come back to this. It is easier to understand with numbers. For example, X belongs to primes,
Mm-hmm.
and then we define the limit. Before that, this set A, x is an integer, and then we define the limits.
Okay.
B, set B, x is letter of alphabet, and then we define that it is a vowel.
Wouldn't it just be
Describe,
like a vowel? Because like there's only like one type of vowels.
yeah, you could write that, yes.
Okay.
Describe each of these sets using set builder notation. So square numbers less than 101. First, we would tell them
X
x is
is
such that
is a number. No, X is a square number. And X is less than 101 with symbols.
there are different ways we can write it. I can say x is such that x equals n square,
Less, but
where n could be, because we've studied sequences, there are two ways. Maybe the second one is the one which you wrote. X is such that x is equals to n square, and we can tell them, I know that 10 square is 100, and I can tell them where n is less than 11.
okay.
And I'll also have to tell them that n belongs to real numbers or natural
Okay.
numbers. And we can say x is such that x square is less than 101, and we can define where 0 is less than x and x is less than 11. What did you write?
X is a square number and X like less than 101.
X is a square number. Yeah, this thing is fixed for everyone. X is
Mm,
such that you wrote that,
yeah.
and then you wrote x square,
No, I wrote X is a square number.
like the words.
Mhm.
You just have to change that into it. This means the same thing, but that is just the writing style.
For the one that we do, like, do we have to put like 0 is less, like X is greater than 0? Can we just put X is less than like 11?
In this case, specifically, square number cannot be negative.
Oh, okay.
Even if you don't write that, still you'll get an answer which is greater than 0.
Okay. So we still have to put the 0.
Yeah. Now, the question of this type, days of week, it has nothing to do with numbers. I can say x is such that x belongs to days of week. C part, integers less than 0. X is such that x belongs to integers, and we write a negative sign with that. Natural numbers which are negative, and
Okay.
x is less than 0. Just the writing style. Look at question number 2. It says express each of the following in set builder notation. So I can say x is such that x belongs
Greater than.
to integer. Let me just confirm. I'm writing R, that is for integers, and natural numbers is R both. Yeah, natural number is this and real number, natural number. I have to use capital N in case of integers. So x belongs to natural numbers, comma. And now these are the numbers 2, 3, 4, 5, 6, 7, 8. There's no gap, nothing. So I can write either I can write 1 is less than x and x is less than 9. And there's one more option. Or I can write x is such that x belongs to natural numbers and 2 is less than equal to x is less than equal to 8. Because we are talking about integers, so when I write more than 1, it has to be 2. When I write less than 9, it has to be 8 because decimal numbers are not there. B
Okay,
is A, E, I, O, U,
so
exactly the same which we did in worked example, vowels.
X is a part of the alphabet, X is a vowel.
Yeah. Now, Nicholas is are the spellings of this word. So we can write exercise that X are the letters of the word Nicholas. D part 2, 4, 6, 8, 10, 12, 14. So all I can see are even numbers less than 20. Exercise that X belongs to even numbers less than 20. Less than and equal to 20.
Okay.
What is E? This.
Oh, they're square numbers. No, they're not square numbers.
They're not numbers. Square is only 4, 9, and 36 in this. Meanwhile, whatever it is, X is such that X. So what is it? You can do that. You can do that. This is 1, 2, 3, 4. It is positive, negative, even, odd, prime. What is
It's
it?
po
Obviously, I won't speak the answer when I'm giving you the hints.
it's real numbers.
True. And real numbers could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of these.
Real
But the
numbers
numbers are,
less than 36, but it's not, it's like it
but,
has
but part is the answer.
1, 2, 3, 4, 6, 9, 12, 18, 36. I feel like it's a combination of like different, like two
What
sets.
is specific or special about? Okay. Is it even?
Yes. Hmm? No,
What
well,
about 3?
no, no, it's not even because 9 is there.
It's not even. It's not odd. Yeah. So not even, not odd, not prime, not square. Now we are left with only answer. Okay, I'll give you a hint. We did LCM at HCF.
What is LCM and HCF?
Lowest common multiples and highest common factors.
What did you ask me? Did you ask me what is LCM and HCF?
I'm just giving you a hint that you can think this way as well. X is a factor of
Factor of 36.
36.
Oh my goodness. That took longer than it needed to be. So whenever there's one that starts with one and then it doesn't look like it has like a special order, then it's a factor of something.
See this.
Okay.
1 into 36 is 36. 2 into 18 is 36. 3 into 12 is 36. 4 into 9 is 36. 6 into 6 is 36.
Okay.
You know what is the special part about classes or notes or syllabus or self-study? You don't have time limit. You can spend as much time as you wish on this question so that you can do it in seconds in your exam. There would be nothing special about the exam. Whenever you look at the question, something will click in your mind that you've seen such kind of question somewhere.
Mm-hmm.
And the method would just question, and you'll just know without knowing the detailed reason, you'll just know the answer is this. Question 3. List the members of each of the following sets. X is such that X is an integer, 40 less than X, X less than 50.
So 41, 42, 43, 44, 45, 46, 47, 48, and 49.
And 49. And in close in curly brackets. B part. X is such that X is a regular polygon and has no more than 6 sides.
X is a hexagon, an octagon.
Octa is 8 sides.
Oh, no more than 6 sides. So it's gonna be like a triangle,
Good.
a square.
We need specific word because of this thing. Regular.
Mm-hmm. So it's a regular triangle. It's a regular square,
Equilateral
equilateral, and then normal
triangle and 4 sided would be
square,
5 sided,
pentagon, regular pentagon,
regular pentagon, and 6 sided,
hexagon, a regular hexagon.
regular hexagon. So this is it. C part. X is such that X is a multiple of 3, and then with comma we define the limits.
It's more than 16 but less than 32. I got 21, 24, 27, and 30. Yeah.
18 also.
Yes, 18, 21, 24, 27, 30, and 33. I know, just up to 30, no 33.
Yep. Number 4. Describe each set in words and say why it's not possible to list all the members of each set. Now,
I
if we
can,
talk about this, x comma y is such that y is equals to 2x plus 4.
I can go on forever.
That's right. Why we cannot list because there's no limit is defined for both of these. So in words, what can I say?
To create a limit for it,
Like what do I tell someone? I have to write a sentence and give them that piece of paper so they should know we are talking about y is equals to 2x plus 4. This looks like sequences.
Mm-hmm.
May I say 2x plus 4 multiple of 2 and we add 4. Let me just write the numbers to be sure. If I'm writing 0, this is 4. When I write 1, 226. When I write 2, 2 twos and 4 plus 4 is 8, 3, 6, 4, 10. So 4, 6, 8, 10. May I write all even numbers greater than 2?
Mm-hmm.
And when
All, and then would that be all negative numbers less than,
we
let's
can simply
say,
say x is less than 0.
okay,
So
less
B
than
part.
0.
Cube of
Oh,
all the numbers less than 0.
okay.
Fifth part. A says x is such that x is a multiple of 3. B says y is such that y is a multiple of 5. Now, in this same question, we are talking about two different sets. So he's using two different variables. You don't confuse. So we don't confuse it. Express A intersection B in a set builder notation. So x is a multiple of 3. 3, 6, 9, 12, 15, 18, and so on. Y is a multiple of 5. 5, 10, 15, 20, 25, 30, and so on. A intersection B, what could it be?
15, 15, 30, and then, yeah, 15, 30, and it can go on and on and on.
You're
Only
right. So what would it be?
x is such as the x is
Let's say A intersection B is Z, and
mhm,
we'll say Z is such that Z is what?
z is a multiple of 5 and 3.
Multiple of 5 and 3. So is it 6? Because
No,
6
oh
is a multiple of 5.
no. It's a multiple of 5 or 3.
May I write 15 is a
Is a,
multiple of 15? You actually answered that when you
yeah,
said
15,
15
30.
and 30.
Mm-hmm.
So 3 and 5 are having an LCM of 15. So every number after 15 would be common. 15, 30, 45, 60, 75, 90, and so on.
Z is a multiple of 15. Okay.
Now, if it was not the matter of words, you were actually in the right place. You already said 15 and 30. So we just need to write it in words.
Mm-hmm.
Question number 6. Universal set is y is such that y is positive and y is an integer less than 18. Positive explained, integer that is whole number and less than 18. So we already know that we are talking about 0, 1, 2, 3, 4, and up to 17. This is our universal set. Now A says W is such that W is greater than 5. These are all integers, and B is such that X is such that X is less than equal to 5. So these are B and all others are A. List the members of set A intersection B.
Well, they both go, there's none.
There's none. So that's
There's
an
none
empty set. There are two ways to write it. One,
or null set.
or we draw the symbol 2, and we can also write these words, null set.
Okay.
Okay. A complement. What is A complement?
It's just B.
It is
So,
B.
yeah.
Then we have to list the members. So we'll write 0, 1, 2, 3, 4, and 5. A complement intersection B.
So everything except for A, but
Right.
so it's just basically B still.
And in this case, specifically, there is nothing which is actually outside A and B.
Mm-hmm.
So A complement means not A, and in this particular case, that is all of B.
Mm-hmm.
So same answer. 0, 1, 2, 3, 4, and 5. A intersection B complement.
Oh, it's just basically all of A.
So 6, 7, 8 up to 17.
Mm-hmm.
A intersection B complement and then complement again. So we already have A intersection B complement in the fourth part.
So it's going to be B.
That is going to be B. 0, 1, 2, 3, 4, 5. What is A union B?
It's the universal set.
Universal set. Very good. List the members of the set in part B. So we just list them down. 0, 1, 2, 3 up to 17. Let's have a quick look at the summary. I personally find this topic a little disturbing.
Harder or not?
Um,
Yeah.
I was always and all the time, and still I am, though I'm teaching since years, afraid of this topic. And that was my fear, which actually led me to get stuck on that question.
Oh, okay.
Do you know the following? I'll just quickly go through it and stop where I think we should discuss. A sequence is element of sets arranged. We know that. And you know that a term is the value of elements.
Yes.
Term is known as elements. If position of a term in sequence is given the letter n, then the rule can be found to work out following nth term, as we did a plus n minus 1 into d, and hit and trial. A rational number and could be written as fraction. Irrational could not be written. A set of list of collection of objects share same characteristics. An element is a member of set. Element, member of set. No is null set, universal, complement, union, intersection.
Subset.
The element of subset that are all counted within a larger set are proper subset. Now, this is not good. He is using this symbol for proper subset. And this is for proper subset. If it is possible for subset to equal larger set, then it is not a proper subset. He's using the same symbol for both of them. For clarity,
Mm-hmm.
proper subset is this, subset is this.
In the exam, it's going to be
Do
like
this
the
in
road and
exam. Yes.
okay.
Like I remember this as well, and we just checked it over the internet, and I checked it at the last time also from different sources. And clearly, he's using the same words but different symbols. So that's a typo.
Okay.
A Venn diagram is a pictorial method of showing sets. A shorthand way of describing elements in a set is called set builder notation. Are you able to continue sequences like write the next two and three terms? Describe a rule continuing. Yes. Find the nth term to find later terms. Find out whether not specific number is in this sequence. And these type of questions mostly included that it is not a multiple of that. We mostly had like 4n or 6n or something. Generate sequence from shape patterns, form, find a formula, write recurring decimal, describe set in words, find the complement, represent member set using Venn diagram, solve problems using Venn diagram, describe a set using set builder notation. Hmm. For our next class, we'll start this and I'll find a healthy exercise for this previous topic to practice over the weekend.
Okay.
You are the only student whose weekend counts from Monday to Friday.
Was weekend only is from Monday to Friday?
Monday to Friday. Every other person has a weekend on Saturday, Sunday.
Oh. Oh no, mine's also Saturday and Sunday.
When I when I tell you that I'll give you the homework for the weekend, so
Mm-hmm.
that's Monday to Friday because we are having classes on Saturday, Sunday.
Oh, okay. Okay.
Set builder notation. Weekend is such that it follows from Monday to Friday. Anything you would like to ask?
Mm,
And usually I crop out few questions from the same exercise for homework, but we've done all of these, so I'll use a different source.
okay.